Welcome to this workshop on fair computational workflows. My name is Ignacio Eguinoa. I'm with ELIXIR Belgium, and together with some other members of ELIXIR, we are hosting this workshop today. So I will first say some words on the practical aspects, because this is a platform which is new to us probably, and maybe also to a lot of participants, and we want to get everyone on the same line. So yeah, this is it. Most of the talks that we have planned are followed by question and answer sections. So for this, we are planning to use the Q&A section, of course, of the platform. Just one thing, because we are expecting quite a lot of people. If you can, yeah, you're always welcome to ask any questions. But if you can also check others' questions from other participants and vote on them, then at least we know which one are the ones that you want to get answered first. So that's a first thing. Then you also have a forum, which is pretty much like a chat where you can discuss, and we will try to get involved as much as possible. Although if we really have that many people online, it's going to be a bit complicated to answer everything over there. So yeah, as I said, ask the questions to the platform question function, both on each other. And one thing is that we may have some sections back to back with 2 or more speakers. If you can, in your question, indicate which person you are referring to, that would be great to have it more. So just a general thing about this, like it was initially planned to be on a face-to-face kind of way, and it still involves quite a lot of discussion, and we expect a lot of input from participants. So yeah, we are always welcoming your questions, or however you can communicate, please do so. Just before we start, one small advertisement. So this is part of ELIXIR. So you will see that most of the tools and the projects that we present today, and also some others that are linked to it, are constantly under development. So some of us, or most of us, are the developers on those projects. And we work with this throughout the year, but normally in November, we get together during a week and do all kind of discussions and cool development in person. So this year it will be virtual, but it's still a great opportunity, and it's a great event for sure, because everybody from different projects will be there, and it's the best opportunity to get things going. I mean, things that really need interaction between the projects and between the persons. So I was told today that actually, yeah, the registration is closing on September 18. So you still have time. You can check the website, biohackathoneurope.org, and then you will see all the projects that are part of this biohackathon. And if you're interested in one, you can just register, or you can also get in touch with the people involved in the project. So,
Ignacio, can I ask, were you expecting to present us a picture there? Because I only see you, I do not see your presentation.
Yes, there should be a small ad about Biohackathon Europe. You don't see it?
We don't see any of your presentation.
There doesn't seem to be a shared screen.
You haven't shared your screen.
That's great. We start from here. There you go. That's the ad on the biohackathon that I was mentioning. So I will just leave it for a second so you can see the the website. But yeah, everything that I mentioned before is just there was no slide for it, so it's okay. So yeah, now for the fun part. Let's get started with the content. And now, so Carole, do you want to step in and start with the idea behind the talks and the organization?
Sure. So thank you for that. And So we wanted to really talk at this workshop about computational workflows and FAIR. Computational workflows have come of age. We have seen that over the last 15 years, they have moved from something that is perhaps rather specialist to something that's much more mainstream. And I show an example here from a paper last year at Nature about the importance of computational pipelines, because of the important part that they give us in order to be able to do the heavy labor of informatics in the life sciences, in particular in data preparation, knowledge extraction, repetitive processing, and to do big science and distributed collaborative science. It's time that computational workflows themselves were fair. And that is, in case you don't know, and you must be the only people who don't in the world, know that findable, accessible, interoperable, reusable is the mantra at the moment of all knowledge developed in the scientific community. Now, next slide. Yep. So within ELIXIR, we've been developing a ecosystem of tools and infrastructure in order to be able to support fair computational work, but also particularly fair workflows. And that made up of registries for various different workflows, ways of packaging and containing and doing portability of workflows, work with specific workflow management systems such as Nextflow, Galaxy, SnakeMake, and also things to do with workflow quality, workflow monitoring, testing, and in order to be able to ensure that as the workflows go through their life cycle of creation, running, and then maintenance, and also of course decay, as they are software, just like any software workflows decay, that we also manage that kind of monitoring. And in the heart of all of this are a whole set of standards associated with describing workflows, APIs for workflows, and ways of being able to interchange between workflows. And you'll see today in the presentation aspects of all of this. So this is a kind of roadmap for the way ELIXIR is working on its workflow ecosystem. Next slide. So the workshop key questions are: the FAIR principles were developed for data, but how do they apply to software and how do they apply for workflows? And the first two talks will be in that regard. Then we have a whole bunch of services and tools that I've just highlighted there in that diagram. What are they? How do they work together? And how can you get involved in them? And we also want to go through what is missing, what else is being currently developed in the FAIR ecosystem, and general discussions and questions around this whole area of FAIR computational workflows as opposed to just FAIR data. Next slide. And so just a reminder that this is how we've broken up the workshop. So first we're going to hear from Sarah and Mateusz about FAIR principles of workflows and software. Then we're going to focus on findability and accessibility, about registries, then interoperability and reusability around standards and ensuring that workflows are reusable because they are actually still in operative mode, and then looking at particular workflow management systems, notably Galaxy and Nextflow. And I'm afraid we're going to have to sacrifice the short talk best practices for workflows at the end because it's proved to be very tricky to do in this very large webinar activity. But we will have lots, we hope, time for discussion. There is some wiggle room in the schedule. And so the first talk that we have, I'm delighted to introduce Sarah Cohen-Boulakia from Paris, who co-authored a paper on FAIR principles with regard to computational workflows, and it is my great pleasure to invite her to give the first presentation. So perhaps you might want to share your screen, Sarah.
I will stop my sharing.
Okay, can you hear me and see the screen?
Yes, sir, we can.
Yes.
We see it in non-presentative, that's it, great. Thanks very much, Sarah.
So thank you, Carole, for the introduction. And actually, I will present a paper with 7 co-authors published recently in the Data Intelligence Journal. So the thing is that when we have to do biological analysis today, and I'm sure you know that like me, we have actually to face with 3 kinds of challenges. The very first one, and this is not new, is the fact that we actually have to deal with a lot of various data sources. They are particularly distributed and heterogeneous. This is not new. This was already the case 20 years ago. What is particularly recent is the fact that we also have to deal with a lot of different tools and scripts available to perform analysis. So when you get your raw data and you have to augment it with public data using script to make your analysis, the 2 challenges are to find first the right biological data to consider and the right tools. And the last challenge, and I should say last but not least, is actually how you are going to combine those available tools, possibly with tools that you have homemade in a sense, to have a concrete analysis pipeline. So definitely what we have to have clearly in mind here is the fact that the very important question is how your data at the end have been obtained. Knowing this is particularly important today, given the high diversity of both data sources and scripts. So this is now a key question to be able to understand and interpret the results you got. So you have a variety of means to perform that data analysis. You can use script, you can use notebooks, and you can use, as Carole already mentioned it, of course, workflow management systems that are now major solution to allow you to perform an analysis. So those systems have a lot of different features that are all particularly interesting. The one I find very important to notice is the ability of this system to perform tracking, meaning both process logging and data provenance tracking, recording actually everything you need to interpret and understand the result of your analysis and the how these data have been obtained. So in this talk, what are we going to consider as computational workflows, where it can be actually several kinds of things. What matters to us here is that you have a clear separation between what we call the workflow specification from its execution. So on the right-hand side of my slide, you can see the Galaxy workflow, and this is more what we can call the workflow specification. You have actually the various tools that have to be then executed, and the link between them are really the future data flow. So it's more on data type point of view. You have compatibility between the output of a given step and the input of the next one. On the other side, what you can see is actually a concrete execution, and this is a snapshot this time from SnakeMake, where here you have an execution of a workflow, where actually we should annotate all the ages with possibly the data that is concretely flowing at the execution stage. This is actually the same workflow using different systems that we have implemented in both versions. So the specification is concise in a sense, and you have a much more, a bigger, let's say, execution. So then any workflow designed with a workflow system will be for us a computational workflow. For notebooks and for scripts, let's say that's more a maybe. The maybe is on whether or not you have the ability to clearly make explicit, make your data flow explicit. And for the script, it's really, again, the ability to annotate the script that you are using. And for that, the good news is that we have solutions or element of solution, for example, coming from Yes Workflow kind of project. So in this talk, I will actually consider fairness on two sides around workflow. The very first one is centering on fair data around workflow, for and from workflow, but it will be about data. And then I will talk about fair criteria dedicated to workflows, where actually we looked at workflows on their own. So don't worry, I'm not going to review all the FAIR principle, but I put the slide on my talk so that you remember the number I will then make reference to. So about FAIR data for and from workflow, I would say that the very good news is that in the bioinformatics or life sciences community, let me say that I would consider we are well-educated people, in the sense that actually we are used to design and to use open ontologies, vocabularies, and services. Solutions like MyAPI or RAPI, the EDAM ontology, are excellent solution that will help us having, in a sense, for free, then data interoperability and, for example, identifier resolution solution. So then, given this as input, a workflow management system will then be able to make informed choice both on the specification phase and on the execution phase. What is also a great news is that we may have this level of metadata information on FAIR data, but also on tools. With the bio.tools tools or the bioconductors, we may have access to a lot of concrete information on those tools. And on the biocontainer, we have this point of view on the container sides. So together, we can hope going to a FAIR infrastructure at one point. So definitely here, the point is that if you have a well-designed workflow management system, then there is big hope that they can really automate the production of FAIR data, both to have automatically metadata description on the data product obtained and the ability to deposit data in searchable resources. So don't think that I'm a big believer and dreamer. I know that we have a lot of challenges still to overcome, even at the level of data. So the very first challenge that we can notice is on the identifiers point of view. The thing is that in a huge execution, the number of intermediate results is particularly high. So tracking data attribution, minting IDs is something that is a complex task. Again, some hope on some recent projects, for example, the MediaID project, are an interesting element of solution. Another point to mention is the licenses point of view. Again, only on the data. Imagine you're using several data sets on your workflow. How can you combine those licenses and what at the end will be the license associated to the data that you obtain at the end? This is kind of a complex question to answer. And the last point is the same, but on data access. Okay, if you have different authentication and authorization on the really access of your data, and you need to propagate it through different tasks, each task may be hosted by different service provider, using different operating system. This is again something that is complicated to deal with automatically. An additional challenge is on workflow provenance. This is to me one of the most important challenges to consider. The good news is that workflow management system provide excellent documentation now on how the data has been generated. And we have seen really a lot of standardization efforts in the last 15 days, I would say. But still, currently provenance lack standard in several ways. First, processing tools. We really need more processing tools on provenance. And the second point is that knowing at which level of granularity we capture this provenance information and then we render it to the user is not as easy as one may think. Two other point to mention here is that we have to keep in mind that workflow may be coarse-grained. You may have sub-workflow that are not tracked in terms of step in a given workflow, and you may have resources and tools that do not report basic metadata. So here, I would say the big piece of hope comes from bioschema, and I know we are going to talk a little bit more about this later today. Another point to mention is the problem of what we call unfair service provision, where actually you are reusing a component, another workflow within your workflow. And at the end, actually, if the component changes its interface without any notice, then your workflow is broken. So this was focused really on data. Now let's consider workflow as digital objects. So if we consider really workflow on their own, instead of having data sources, we should talk about workflow sources. And this is what we call workflow registries. So the one that we have today are particularly, I'm impressed of what they contain today. And it is really new. This is something that popped up currently, and this is an excellent good news, I would say, in the last 5 years, let's say. So we have 9hub, NF Core, SnakeMake wrapper, and having this already help having a lot of different fair criteria that can be considered as taken into account. Still, we have a challenge to consider, for example, on the access point of view. And still here, we are talking about workflow registries dedicated to workflow management system. So if we consider now solutions that are more agnostic to the system, that's my personal point of view, but to me, my experiment is one of the most important from the research point of view, systems that have been designed in the last 15 years. Compared to when I started my PhD, and now my experiment changed a lot of research point of view. So it really was a pioneer system, the very first one to consider workflow finding, sharing, publishing. The licensing point of view was already there, and it really laid the foundation for workflow-based research objects. As far as I know, there is now in the EOSC Live a workflow hub project that sounds really terrific. And I will let Carole present it in a few minutes. So this was actually, when we consider workflow on their own, we have the idea of workflow registry, and we have the idea also of workflow description. We are not going to describe a data, we are going to describe a workflow. So then again, in the last years, we have seen several very interesting new projects on that point that will help us enable interoperability. So as far as I see the community, I would say that the common workflow language is definitely one of the most used today, or actually visible, at least in the dedicated life science community. And again, we will have a dedicated talk on that, so I will not enter into the detail. What I would like to say at this point is that it's important to have in mind two things. Workflow as description of processes, as its description, its metadata, and they will actually inherit property of fair data. So this part description of processes, workflow, in a sense, can be considered as data. But they are also executable processes. So in this sense, they also inherit properties of software. And making the two compatible, let's say, is kind of a challenge in itself. So about challenges, actually, we've considered 5 challenges so far on that subject. The very first one is on the structure. Okay, workflow means nested workflow. We want to reuse, we want to share. So we are going to have nested workflow, reusing sub workflow. But then in terms of FAIR criteria, this means that we may have FAIR criteria applied at multiple levels. And we may have a lot of incompatibility at this point. Okay, let's take licenses. Another point to mention is that identifying, citing, composite, multi-author project is kind of an open question. There are a lot of problems, again, in the granularity of what we want to keep track of to answer and to decide if we have to consider new FAIR criteria. The second point is on the form of the workflow. What do we mean by FAIR workflow? A CWL specification, its implementation and instantiation, a run result, all of that can be considered as FAIR workflow. But at each of these forms, we may have different FAIR criteria. So again, we have to think about a solution where this combination makes sense. Then to other point, versioning, workflow are living artifacts. So workflow evolution is a form of provenance in itself. For this, I particularly like actually the inif core solution, where we have, in a sense, a natively versioning point of view, plus the ability to test and to validate. FAIR workflow must also address fixivity, the ability to actually say that I have a snapshot of my workflow execution and my workflow and its dependencies to fix its reproducible state. I know that at this point, the workflow is reproducible, and I should, in a sense, be able to identify this snapshot with a persistent ID. Another point is that workflow are executable objects. So they are for sure Singularity, Docker, Conda, Bioconda have been a revolution in our domain. They were alive before and after that kind of project. So now we can concretely talk about reproducibility. Before it was more a theoretical point of view. But still, we have to think that a workflow and software tool are limited time objects. So their active lifespan is actually dependent on several points. Their component, sub-workflow, for example, the workflow management system where they are running. And my understanding is that for those points, CWL is already able to even maybe partially, but already answering part of those points. So I will let Michael talk about that later. I'm almost done. Another challenge to have in mind is on the reuse. So reuse, you know, you may consider reusing exactly the same, changing a bit. So repeat, replicate, reproduce, I change more things, or reuse, I actually take half of my workflow and reuse it possibly in another context. In all those solutions, it's particularly important to have the ability to test workflow. And this is also something that, in a sense, there should be more both practical solution on that and even research point of view on that. So I've seen that we will have a talk on the open bench solution later, and that will they will actually be perfectly describing what is done today. Another last point to mention at this point is what about the parameters of all that tools? Well, again, the parameter should be fair. So even though it's of course time consuming, there are already projects that consider the fact that parameters of tools are well documented. This is, for example, the case of the biocompute object. So as a conclusion, let's say that workflow capture complex method, fair property are needed. The thing is that fair principles for data and software are applicable, but they need to be extended to capture the processual nature of workflow. We need to have appropriate fair principle for software, incorporated best practices, and we really need to think deeper, in a sense, on the combination of all these individual part, forms, version, execution environment to consider complex interdependencies to be covered by those new, possibly new fair metrics. So to finish that talk, I would say that I'm a strong believer that verification of workflow is something that we should really work collectively on because it's the solution to pave the way for trustable data where we will actually have really data that are added value ready to be reused by third parties. So I'm done. I thank you very much for your attention. I hope I'm still there. And I thank, of course, first of all, my co-author and all the colleagues that I have from ELIXIR France. And I exchange with them a lot for that. So thank you very much.
Okay, Sarah, thanks a lot. It was a great talk. Let's see if we have some questions. I do have one, although we don't have a lot of time. Just a quick one. You mentioned that the provenance collection was kind of a failure, if I get it right, in terms of what the workflow management software collect. And what do you think is that? I mean, I guess workflow management software mainly focus on analysis part itself and trying to get the workflow running, but is any of them actually good at collecting provenance? And if not, why is that case?
I mean, I was not saying that they were not good or bad. I was saying that to me, it's a research problem. Imagine you collect everything. Okay, you have exactly all the data that have been used, even all the intermediate data. Then how can you provide this to the user and hope he will then be able to use that to interpret the data that has been obtained at the end? So this was part of my research topic. I really think that tracking is already a problem, but today the different systems are now able to keep track, but then being able to allow user to exploit this provenance information to think about new experiment to conduct, to avoid being, having an avalanche of data provenance is not helpful. If you tell to your user, look, you have these 3 GB of data that have been used to produce your data, so what? What should we do then? This is complicated. What should you hide? What should you focus on? How can you consider various levels of granularity of presence information? This is not that easy.
Okay, got it. Perfect. Okay, thanks again. And first of all, before moving on, just one thing, because somebody asked about the recording of the video. I got info from the organization that is taking care of that, and they are the ones that will later let everyone know where they can find the recordings and so on. So it's up to the organization of the conference. So next one, we have Mateusz Kuzak, who's gonna talk about FAIR for research software. Mateusz, you there? Can you? Awesome. We can't hear you though.
Yes, yeah, I was looking for my unmute button. You can see my slides and you can hear me now, yeah? Okay.
Yes.
I will introduce the initiative that I have been involved in, which is working towards defining and implementing FAIR for research software. So I will not answer your questions how to make workflows fair, but hopefully in a while from now, we will, thanks to this initiative, of course, not alone, but also with other. First of all, the first principles at the high level are intended to be to apply to objects which are both used in the research, so to do research, but also the outputs of the research. So software is an example where it is used to do research. But of course, you are very aware of it. It's much more complicated often than making data fair. And this initiative is looking into how to adapt and then later adopt those FAIR principles to research software. You can also see here the URL to those slides, but they are also linked, so I believe they will be distributed. So this work started already a while ago. There have been a lot of different initiatives looking into fairness of research software, but the group that I'm talking about has been somehow kicked off through the RDA plenary meeting. There has been workshop Fair for Research Software early this year. It was an online workshop where some of the people who co-authors of the Towards Fair Principles for Research Software paper have been present and coordinated this workshop. That there was clear that there's still a lot. So the paper that we have been discussing has been a good start into like thinking about Fair for Research Software, but we actually need to do some work to figure it out, to see how those principles apply and how we can implement Fair Research Software. So to give you an overview of the initiative that has been happening before actually we started our work, there has been multiple workshops at the workshop for workshop on sustainable software, the ELIXIR workshops, DTL workshops. So the first thing is actually to have an idea of what has been generated or like what has been the output of those different initiatives, and that part of that we already did when we're working on the paper that I already mentioned. And the group that I'm mentioning, this is a group that started with this RDA meeting, but actually it's more like a hybrid working group. It's an RDA and Force 11 working group, and also Research Software Alliance Task Force, which is nice because it combines people coming from different organizations from a little bit different backgrounds. We have very nice diverse group of people in this group, contributing to this group. And the focus is on, as I mentioned, is defining and effectively applying FAIR principles to research software, and then later on adopting, like achieving the adoption. So the deliveries are the definition of the FAIR principles for research software. That's what we're focusing on in the upcoming 6 months. And I will mention, I will talk a little bit more about how we're going to do it, or how we are already working on it. And then developing the guidelines on how to apply the FAIR principles for research software, and following that, and adoption examples, so that we can show others how they can use this to apply to their own research software. So the first part of this work we're doing in subgroups. So these are subgroups of this working group. Everyone is invited to join us in those groups. So we already started over a month ago, but everyone can still join. And I think especially the second subgroup here is very relevant to this group of people in this workshop. But I will briefly describe what are those different 4 different subgroups. There's one is looking fresh at FAIR for research software, so not being biased by the paper that we published, try to forget about it and think about it again. And then the second is about fair context, fair work in other contexts, and it's also research objects or workflows. So it's research objects, that's, among them that's workflows. And then we need to define what we mean by research software before we actually start thinking about how FAIR applies to research software. And the last one is looking at the new research, because while so we have published the paper, now we're working on it, and the world moves on, so things are happening. So we have to keep an eye on what's popping up, what has been worked on in the meantime, so that we kind of include this in our work. So again, everyone is invited to join those groups. You can contact me. The links are in the slides, so you can also go from there. You're invited to join the RDA working group. And we have presented those working groups in more detail at the RDA webinar. So in the slides, you will also have a link to the webinar, so you can watch the videos, the recordings. And yeah, that was very brief. Thank you.
Okay, thanks a lot, Mateusz. I don't know if somebody from the ones in the speakers in the webinar have some questions. I just have one. I mean, I only got to know this very recently, and it's nice to have you here speaking about this, because I know it's moving forward really fast. You mentioned a kind of deadline for the outcome of it, saying something about 18 months or something like that for the
for the whole working group.
Yeah,
that's 1.5 year. So the first 6 months are for the working out the adaptation and the defining the FAIR principles, and then adoption, and then the examples. Yeah. Okay, cool. So did I get it right? That's starting from when? When did you start? In November? We already started. Yeah, indeed. Yeah. In November last year. We started. So officially, the group. Actually, I think that the RDA group officially have been started very recently, a few weeks back, if I'm, or it's happening now. I don't remember exactly. But we started work already before we got the approval of the RDA working group. So we have been working on it for around over a month now, in the subgroups. We did have meetings of the working group before that to actually plan in advance and to create a proposal, because we had to start with proposal for the RDA actually to get the working group started, which is the formal process. So we had a group arranged, and then we wrote what we actually want to do in the working group. And over a month ago, we started working in subgroups. So already working on those the deliverables for the working group before we even had a working group. Perfect. Yeah, now I get it, because I only got to know this like a month ago, indeed. Okay, thanks a lot again. Now, thank you. Just a very brief comment. If you want to ask questions during the speaker sections, just do it through the live Q&A section. Is on the right side of your panel. Yeah, they will be answered in the Q&A sessions after the speakers. So next one, we're moving to the mastermind behind this. Yeah. So welcome to Carole Goble. She already talked a bit about it, but welcome again.
Thank you very much. I don't know about a mastermind, maybe a godmother instead. I was delighted that Sarah's a lovely presentation, because she set up very nicely. It's a presentation about the Workflow Hub and the bioschema workflow profile that she mentioned. And this work is with a lot of people who I will acknowledge at the end, who form part of the Workflow Hub Club. So the context of this work is ELIXIR are leading a very large cluster project called European Open Science Cloud Life Project, which has 13 of the European biomedical research structures who are attempting to build a shared commons of tools, data, workflows, computational resources, and so on for collective research. And this has created a zoo of all sorts of things, in particular a zoo of workflows, workflow systems, and repositories that support those workflows. So at the moment, the Common Workflow Language lists 100 to 180 plus workflow management systems. And there are numerous workflow repositories as well that go along with those workflow management systems. Some are just normal GitHubs or GitLabs, especially dedicated to projects, and some are specific to the workflow management systems that they serve. Some are agnostic to workflows, and some are specific to a particular kind of workflow management. And Sarah mentioned my experiment, which was an early one we developed in 2007, which kind of pioneered the idea of an agnostic workflow management environment. Because at that time, we recognized that workflows are knowledge assets in their own right. As Sarah identified, they're explicit method that can be tried, tested, and maintained for the use of other people. They're also records and recipes of know-how and also what occurred, histories to be reviewed and reused. They're mechanisms of reproducible science and scholarly publications in their own right. And they're also mechanisms of democratizing processing and computational know-how to a wider community. Somebody can find a workflow and they know about a workflow platform they can run it in, they can use it. But they're often complicated, they need explanations, and they are challenging to develop, run, and keep up to date, and one would like credit for that. And they can be challenging to find and understand. And these ideas were developed early on in this My Experiment workflow repository at that time. But times move on, and so it's time for a refresh. And so as part of the European Open Science Carole Life project, we're developing, and others who have joined in, we're developing the Workflow Hub. So the Workflow Hub is surprisingly a hub for workflows, to aggregate workflows across the community of workflow management systems, to act as a registry for workflows that remain in their native repositories and in their native forms, but also to serve as a repository for perhaps workflows that don't have a native place to live, for example, scripts. But particularly to pioneer the idea of common registration metadata, some canonical workflow descriptions, so we can kind of get a common richness to the registration of the workflows in the registry, to register, so they're pushed, and harvest, so they're pulled from these native repositories, to import and export workflows as research objects to and from workflow management systems, and to basically support and generate community standards. But we particularly want to emphasize that the makers of these workflows are custodians of their own workflows, and they should also have credit, so that should be preserved in this infrastructure. This also gives us an opportunity to have some added value services, for example, richer metadata and packaging, to provide a place for supplementary data such as test and example data, as well as being a registry for them to be published as supplementary workflows in their own right, to be associated with publications, to form collections of workflows, to support the life cycle that Sarah pointed out, which was versioning and snapshotting, and also to link up monitoring and testing services in order to be able to maintain that liveness that she talked about. It is not an execution portal, so one doesn't run the workflows from this. It's executions are handed off to workflow installations and execution environments. So the prime stakeholders of this new workflow registry are workflow makers and script makers, workflow management systems and all the related trades associated with workflow management systems, for example, tool and container providers and workflow monitoring infrastructures, and projects and research infrastructures and those who support them, so that one would be able to find workflows that have been funded or developed in those projects. So this Workflow Hub was started up in this project, but it was accelerated. So a little bit of background, it was fast tracked for COVID-19 panic. So it has been stood up since April 2020, but in a very kind of alpha form. So we put it up 6 months early, actually, and we put it up through the biohackathon, the COVID virtual biohackathon, which we acknowledge and thank. And it's been listed. This has been listed now on the COVID-19 data portal from the European Union. So the workflow hub for COVID and the workflow hub, it's sort of primary and now the same thing, because since June we've been taking non-COVID workflows. But it does mean that we have done this in a very daring way of perpetual development in the open. So we have been helping folks registering their workflows. There's very regular releases of features, and it's very agile because we have done it rather daringly quite a lot in the open. So a bit of run through. We have, here's a landing page. There's mechanisms of being able to organize workflows and their makers in teams. You can associate sample and test data. You can organize workflows into collections. There's obviously at the bottom you can see information to do with the new additions and downloads. I should highlight that this has been, we managed to put this up very quickly because we built it on an infrastructure we already had called the FedMSeek. This is a view of a sort of library of the workflows. So you can see on the left, there are lists of workflows with a faceted browsing and tagging associated with it. As of now, we had 47 workflows in this alpha phase release uploaded. So we have, you can look around and see things by their creation date. You can look at things like markers as to whether the workflow is considered to be stable or is work in progress, who has put the workflow up, what team the workflow is associated with, and so on. So you can organize your workflows as teams. So we can support team working. This is Galaxy project SARS-CoV-2, where there are 21 workflows associated with this project. So the submitters of the workflow get credit, and the contributors who make the workflow get credit. So here's a site of a workflow page from that particular team. It's a Galaxy workflow, and here it's being presented in its native form. It's got a status indicator that says it's stable. So those of you who are familiar with Galaxy will see this familiar look. You'll also look at the right-hand side and see that once you've found this entry, you can export it in two ways or use it two ways. The first is you can visit the source and go directly to where this workflow is in Galaxy Europe, the Galaxy instance that will run it, but also you can package it up and download it as something called a research object, which is specified in the workflow research object crate, RO crate. There'll be a fuller talk about later on, although I will give a little bit of summary later on. That allows you to download it as a packaged object. And in progress, we will also be allowing you and implementing full links into GitHubs, where people are developing their work into GitHubs. But you also see that we have metadata extraction for inputs and outputs at the bottom, and the steps, licensing, metrics, contributors, and so on. There are more workflow types than Galaxy. There's Nextflow, the common workflow language, Make, and we have another catch-all for scripts, for just scripts. And we are adding new workflow types as we go along. We're trying to use the common workflow language as the canonical description of a workflow. So for example, this Nextflow and CWL workflow, which comes from the Verify project, is actually the same workflow, but rendered using two different descriptions, the native one and the common workflow language. And of course, using the common workflow language gives us benefits of a canonical description across workflow systems. But that means that we have workflow management systems have to produce that common workflow language description. And here indeed is an example of Galaxy, a Galaxy workflow that has been rendered in what's called abstract common workflow language. So that's not an executable CWL, but it's a description of the workflow. And again, to the right, you can see that you can download this as a package. But to describe a computational workflow, we have three main pillars. We have this workflow research object, which allows us to organize and package together the components and forms an exchange format for workflows to and from the hub, from the workflow management systems. We have the common workflow language, which we use as a canonical description of the workflow, both in its own full fat form, but also as a description alongside a native workflow description. And we also have bioschemas, which Sarah mentioned, metadata about a workflow that you can use to register it and to find it, which is an encoding, a way of representing the minimum information for the registration of a computational workflow, which we have developed. Now, all of this requires working with workflow management systems to support these descriptive mechanisms, to auto-extract metadata, to generate and mint the various different descriptions and packages. So just a hint towards a workflow research object crate, this will be talked about later on, but this is just basically a way of packaging together different files and elements, including references to external objects, so URLs, and so it's not just completely encapsulated files. The workflow research object crate is a specialization of a lightweight way of packaging together this specification using schema.org annotations and JSON LD. And while we're on schema.org, we want to be able to mark up our workflows with metadata, and it has to be said that metadata provided about a workflow by workflow makers and by workflow management systems themselves is highly variable, shall we say. So one mechanism we can use is to leverage schema.org, which is web-based markup, which is led by an organization of search engines to do structured information in web resources. And on the right, you can see Tim Berners-Lee showing that the markup that is used in our info boxes that we're so familiar with in Google. In schema.org, which is a project sponsored by ELIXIR, we tailor schema.org, bioschemas tailor schema.org to introduce new types and properties for life science resources, and to specify profiles over schema.org types for the essential properties used for describing a resource in the life sciences. So because it's a very vast collection of possible terms. In order to be able to do that, we have developed, along with a group of workflow management systems and other collaborators, people building these research object crates and so on, a minimum information for the registration of computational workflows, which surprisingly has metadata elements that are we consider minimal, mandatory, recommended and optional fields. And then we encode this using schema.org. We use this in several ways. We use it for workflow management systems to mark up so that we can harvest this into the workflow hub and also harvest it and use it in the research object crates. The former for being able to do searching and extracting and for being able to acquire this metadata for discovery, and the latter for being able to help us with validation. And this means that, of course, these metadata are then available to other registries and aggregators and services, but we also need to work with the workflow management providers to be able to raise these annotations in their platforms. We don't want workflow workers to do this. We want the management systems themselves to be able to do this on behalf of the workflow makers. So this is just a glimpse of the kinds of things that we have. To the left is the profile, the mandatory elements that we have for computational workflow. And we have two different kinds of profile descriptions to describe a workflow, to describe a parameter. Again, this was a very important point that was made by Sarah, that it's important to be able to record parameters. Well, we also introduced 2 different types. So a type is a new type in ISCB.org for computational workflow and for parameter. I won't go into the details. You're more than welcome to join the community. Again, it's an open community, just like we just said, that his community is open. So here's an example. This is a workflow in the Workflow Hub on the left, and you can see all the markup in it. And on the right, you can see the embedded markup in the web page if you viewed the source. And this is bioschema based. So the Workflow Hub follows the ladder principle of FAIR, because FAIR is a journey, it's not a destination. Hardly anything is really fair. So it's important for us to have support incremental capabilities for different workflow management systems, and the ability to acquire incremental metadata, and to support scripts to fully fledged workflows, and to be able to handle the life cycle as well that Sarah pointed out of revisions, curation, monitoring, and to try to make moving up the ladder as pain-free as feasible, and to spot when we're sliding back down the ladder. So this means we have a whole bunch of different mechanisms. So from the simple, so one can just go onto the website and link together a collection of files and upload them, and links to files, and upload them into Workflow Hub. And Workflow Hub will then mint you a research object that you can then export to other systems. There's an advanced form for workflow management systems that can package together and generate this package of workflow components, which then Workflow Hub can take on. And the future, we are scheduled on our roadmap to do harvesting over GitHub repositories. So there are multiple different ways of being able to get things in and out of the Workflow Hub. We also want to be able to support the workflow lifecycle of living software. So these research objects within the hub are also snapshotted and versioned as they go through their evolutionary cycle. We're working with Life Monitor and OpenEbench to do workflow monitoring. And we have things like status indicators to indicate what status the workflow is at, as well as supporting incremental, as I mentioned, because we do not expect all the metadata to come at the beginning. We expect it to be incrementally collected as we go along. So we have these planned integrations with other registries. This is on our roadmap as well, that were also mentioned. So the Workflow Hub becomes a part of the ecosystem and becomes a FAIR resource, as well as containing FAIR content. And these are 2 different aspects that Sarah hinted at, with several mechanisms of being able to do that, support that fairness through bioschema markup, these research objects, importing and export APIs, and specialized APIs like the Tool Registry Service API. This does all mean that we must build partnerships with workflow management systems, and this is perhaps where we deviated a bit from our old world of my experiment, where we basically had a repository. Here we're looking at a registry, and we're looking at incorporating workflow management systems as partners right from the beginning. And we are honored that we have particularly very strong partnerships with Galaxy Europe and the NetFlow and NF Core community, as well as SnakeMate colleagues, and increasingly new colleagues. For example, Skypian is a new workflow management system who's joined our partnership. And this is to really support mutually smooth and sustained integration paths for metadata, for import and export, for understanding their processes, and to help with added value services. And for this, we have workflow management systems champions. One of you have already heard from, but Bert is another champion. These are the champions for Galaxy, and they come from VIB, from ELIXIR, Belgium. Along with those champions, we have a Workflow Hub Club. So we're developing the Workflow Hub very much in the open, as I alluded to right from the beginning. So it's very important for us to have this workflow management system advocacy and user advocacy. And so we have a distributed team. We have weekly meetups, lots of hackathons, and those hackathons aren't just tech hack. We're looking for people to help us devise flows of information, support, develop guides, help with curation, work with governance. And the screenshot is of a hackathon we had at the BCC CoFest this year. So in conclusion, the Workflow Hub is there about fair workflows. So we find and access, so the F and the A, with this registry of identifiers, versioning, persistent machine processable metadata, and also that the content is accessible and downloadable as research objects, but also accessible in other ways through directly linking to the workflow instance, as in the Galaxy Europe example, or in due course, the directly go to the GitHub. But it also hopes to go further with interoperating and reusing. So by promoting metadata against standards, for example, like CWL and bioschemas, by supporting this packaging portability through the research object mechanisms, through providing explicit licenses, versioning, provenance. And the hub itself is interoperable with other registries and with workflow management systems. So we have fair content, and we also have a fair registry. So with that, I want to thank this is a small number of the people who've helped, and I've also highlighted the people who are really core to the activity. And I urge you to join the Workflow Hub Club. It's open to everybody. And we are pleased to acknowledge all of these funders and projects that are helping us on the way. It's expanded well beyond the bounds now of EOSC Live and ELIXIR to other projects in the European sector. And we also thank very much two hackathon partners, particularly the virtual COVID biohackathon, which was really got us going. And with that, I thank you.
Okay, thanks to you, Carole. It was awesome, as always. So we do have two questions at least. If we can go through this quickly. First one is, are workflows created in some way to be accepted to the Workflow Hub?
Yes, though I hope now that the talk is complete, you can see that workflows will be accepted to the Workflow Hub in a number of different ways. And we go from the sort of lowest common denominator, which is just as collections of files, to the highest common denominator, highest level, which is fully packaged as a research object, which will be talked about later on how to do that. So we attempt to take what you have. So if you only have a script, we'll take a script, but there won't be very much metadata on it, and we won't be able to do, it won't be very rich. But if you are using a Galaxy workflow, then the Galaxy community are working hard so that you as a workflow maker, you'll be able to just export to through Galaxy into the Workflow Hub, and also be able to re-import from the Workflow Hub into Galaxy, and that would all be implemented as part of the infrastructure, and there'll be all points in between. I hope that answers the question.
And there is one more question about licenses. It's how the licenses work for the tools included within the workflow, or one has to provide the license of the workflow instead.
Okay. So this is a very interesting question, and one of the issues that we're addressing in the next couple of months actually is we provide all sorts of mechanisms for providing the licenses, but the licensing issue is a confusing one. And so we want to be able to simplify that. So we're talking here about the licensing of the workflow. But of course, there are issues to do with the licensing of the workflow that inherits from the licensing of the tools itself. So really, we're here we're looking at the licensing of the workflow, but that is not a particularly simple question. It's a simple question to say, here are all the licenses, choose one. it's less of a simple question in order to be able to say, what is the license? And so that could be an interesting discussion for later on if we have time. I know that Mateusz will be very interested in this from the point of view of the Research Data Alliance, because part of the issue of the FAIR for research software is how do you deal with licenses in this composite and compound environment. But also Stian, who will be talking about the research object crate, is a super expert in the complexities of licensing, and I'm sure he will have something to say.
Okay, that will be it for the moment. With that being said, I say thanks to you again, Carole. We'll see you later because yeah, we have a discussion section. But for the moment, I will need to present, yeah, he's already here, Michael Crusoe from the CWL project and ELIXIR. You in? You're muted though.
I've learned that you should unmute before you share your screen. Pardon. So sorry for that delay. Hi, I'm really excited today to be talking. We've heard a lot about the Common Workflow Language. I'll be quickly reviewing that, talking about the new version 1.2 of the CWL standards, and also looking into provenance, which we heard earlier from Sarah in the CWL Prov RO profile. So just as a reminder, we heard a lot about workflows today. The word workflow can mean a lot of different things. And for the purposes of this talk in CWL, we mean batch style automated data analysis, pipelines made from command line tools. Sarah referenced the idea of workflows that connect to other things like other services or sub workflows and the complexities that brings when that can break. But for CWL, we kind of mean self-contained workflows. You're not interacting with remote services. You're not interacting with people. There are other standards and frameworks that address those sort of business process workflows or orchestration. So the Common Workflow Language, as you may have gathered or heard about already, is a standardized specification that tells us how to describe the tools we use in our workflows, how we connect them together. And it's not just for academic or abstract reasons. These are executable descriptions. The language was designed for portability so that you can have a workflow that works on your laptop, on your HPC, HTC system, your grid computing, and on cloud computing. So it doesn't make assumptions about the infrastructure. It makes you explain exactly what you need to do to give this flexibility. And of course, it supports any software container technology that's compatible with Docker, but also locally installed software. So standards are kind of useful. They help us achieve some of the FAIR principles. They enable an ecosystem, and there are also some work. CWL started back in 2014 at a CodeFest, the Bioinformatics Open Source Conference. And this year, just 6 years later, we've now released version 1.2 with the much anticipated workflow conditionals feature. So I'm not going to go too much into details about how CWL works. I'm happy to talk about that since I see we're a bit over in time. And I want to kind of touch more on some of the themes about fairness and then CWL Prov. One thing I do want to say, in CWL, we try to support the FAIR principles, though it's just a standard, right? CWL is not a workflow management system in itself, though there are workflow management systems that implement CWL. So we put a lot of effort into the design of CWL as a language to be well structured enough to enable the realization of the FAIR principles, but also to do in a way that helps us be well performing and helps these different systems be optimized. So something we did to support the FAIR principles was we always think of our data with URI. It's got some sort of identifier. But this actually benefited us with portability because data, it's not just a path, a string. We always know this is a file, this is a directory. We know a lot about it. So it helped us helps implement the FAIR principles, but also gave us a lot of technological advantage. Like the Workflow Hub and other projects, CWL is run in an open basis. It's free to participate. It's free to contribute and to read and make use of the standards, which not all standards are like this. So we take pride in this extra effort. So let's, there's many implementations of CWL. You see the URL for these slides if you want to click through and read more about this. I mentioned the different computing environments, and now that there's an ecosystem. So here's a picture of a CWL workflow from EBI, demonstrating that not only does this help the FAIR principles in sort of execution, but it also helps this, so not just this reproducibility story, but also this reuse story about communicating what we did. So we also aimed that the words you use to describe your workflow, the names of the steps, the names of the data, we want them to be meaningful so that other people, not just the computers, can make sense of them and learn about them. So for example, in this diagram, the workflow has been simplified by grouping conceptual steps that are conceptually related to each other into a sub-workflow, here colored in orange, or if you can see my cursor, I'm circling them, the 3 sub-workflows here. So we've got a lot of adopters and users, and not just from the life sciences. Extensibility is really important in a standard, and actually it's how the CWL standards grow now. And so we always encourage people to help us move beyond and don't let the standard get in the way. Actually, an example I didn't get time to put together a slide for is there's a proposal for an MPI extension. If you've got a step that needs to, or you'd prefer to execute using MPI, we have a proposal that will enable engines that know about this extension to manage the MPI portion, perhaps in interaction with a software container. And as that matures, that might make it into a future version of the standard. So I mentioned CWL standards 1.2 was released this last month in August. All your old scripts are forward compatible. We have an upgrader, and oh, I have a typo here. Support for 1.2 is coming in a variety of workflow runners, though it's already out there in the reference runner and most of the way in Toil. I think what may be more interesting for the workshop today is talk about provenance and some work that Farah Khan, Stian, Soiland-Reyes, myself, and supported by others did, which is CWL Prov. Now, I'm not a provenance expert. I came to the world of provenance pretty intimidated. There's a lot of existing standards out there, there's a lot of complexity. But it was nice to support these two as they dived into the world of Prov and said, how can we piece together the existing provenance standards to pull out all those wonderful details we know that the workflow management systems have and be able to structure it in a single document or a collection of documents. So I'm going to show a couple of figures from this paper. You can find the DOI in the slides, where we again took a structured approach saying that, we want the real raw details that are very specific to an execution of a workflow, almost like reading the troubleshooting logs. We call this kind of level 0, all the way up to this level 3, very specific domain-specific annotations. So the goal was to design a format that would support kind of everything in between, whereas level 1 and 2 are very structured. It's talking about what actually happened as the workflow executed. We'll give identifiers to the steps and the tasks. We'll connect all those pieces together. And then level 3, we want to support what the user might bring. maybe there's a community specific vocabulary they use. We want to expose those annotations throughout the workflow. And, you know, maybe this is actually a nice way to share, hey, I ran your workflow and I had a problem. Let me share the CBL prov output because it's going to give you that structured look at my debugging logs. So while I think Carole Goble might call this almost a confusogram, this figure shows the connectivity and all the different things that were aimed to be captured in CWL prov. We want to capture what was this invocation, what were the inputs. We want to make sure we have a copy of all the whole workflow, references to any software container that was used, including checksums, even if that wasn't in the original instructions. And we also take snapshots of the intermediate products. Currently, CWL prov produces a really fat research object that contains all the intermediate data files. But future versions, we will have a slim profile. So, you know, this was a very CWL specific examination of how can we structure using existing metadata standards. But we hope that in the future, this approach could be extended to non-CWL based systems. But it's still a bit early. So we need to see adoption in other runners and produce slimmer versions of these profiles. As Sarah alluded to, right? How much metadata is enough? How much provenance is enough? It can easily overwhelm you. You don't want to, if there's 200,000 steps, you might not want to know about all of them. So another thing we were asked to talk about is kind of missing pieces when we think about workflow management systems and the FAIR principles. And so I have a paper I'm writing that talked about this. And so I pulled out some of my notes here. One issue we've run into is there's not a known place to get an identifier for any piece of software out there. Bio.tools covers a lot of bioinformatics, but not all of it. And there's a lot of non-biology related tools. And of course, the use of workflows outside of bioinformatics and biology is significant. And Sarah also mentioned my next point, which is that passing of metadata. And here when I say metadata, I truly mean metadata. So data that is not going to change how the analysis works. Sometimes we have things we call metadata that does change that. It's important for the analysis, but sometimes we have this purely decorative, yet still important metadata. And we don't really have we have a proposal, but we need some more work to see how can we pass through this metadata and make sure it ends up on our final products, which might be very far removed. And then also just thinking about the FAIR principles, one of them is that you should be able to get the metadata about this thing you're trying to be more fair about. So if it's a software tool or workflow description, you should always be able to retrieve its metadata, even if that thing doesn't exist anymore. And I don't know who's going to provide that. So maybe the Workflow Hub will provide that for workflows. Okay, if it gets funded, but what are we doing this also for tools? So I think another interesting thing for us to consider some of the gaps we've seen. So I just want to leave some time for some questions. I also know that we're running late in the schedule, so I'm happy to go into more detail about anything else I've discussed. Thank you.
Thanks a lot, Michael. Let's see if we can wait a little minute for some questions. I see that they're asking again about the workshop materials. Yeah, sorry. So we are getting them all together. I mean, I'm talking about the slides mainly, then the video recording, and we will try to distribute that together with the video. So you will hear from the organization on when and where to get it, the slides. Besides, some presenters already share the slides independently, so you can use that too. Okay, if not, then you're welcome in the last part, in the discussion section, Michael. We'll surely have some topics to talk about then. Let's see if we have some time for that. So thanks again. And for the next section, we will have finally packaging workflows with Arrow Crate. Stian, do you want to start with it?
Do you want me to drive and then you take over, or opposite?
Yeah, that would be better. If anything, I will also share my slides afterward, but yeah, just start at your pace.
There, is that coming?
Yes, looks good.
Okay. All right, so I'll talk to you quickly about this mythical Arrow Crate that have come up a few times now. So is research object evolution. So I don't luckily need to remind you about the FAIR principles because Sarah's already covered this. I just want to remind you again, if you read them, you will see it's all about making metadata machine readable. So don't forget that the whole thing about the FAIR principles also making computers being able to extract things with the right guidance from the programmers, of course. And part of that is also which vocabularies you're using and to make a formal, somewhat formal language. I just want to show you here a paper found by Bob Finn and others from EBI that I thought was really good. Not that I understand metagenomics, but the level of details provided on the method section is among the best I've ever seen. You see all the tools listed with other versions and so on. Yet, for the computer, this is all nonsense, right? It's just a bunch of words, right? I cannot easily say, show me a workflow that uses checkm, right? It would not find this paper, right? Or just to find, is this the latest version or whatever? You cannot do something like that. So you cannot run this, right? You will need the execution. Luckily, they have actually also provided that. And you will see in reality, the workflows is not always nice and pretty and all in one beautiful workflow system. You see here 70% R, 18% Python, and of course 10% shell script. You always need a bit of shell scripts, right? And there you see, hopefully, the same data as in the paper. But as you see, there's no structural index in here, right? It's just like, it's just a dump, right? And that is the way we are used to getting materials these days. But this was the motivation for why, I don't know, Carole, is it 15 years ago now, we started thinking about research objects and to augment the traditional publication, not enough to just do a PDF, right? You don't, not just enough to have the text, not enough to just have the supplementary figures, not enough just to add some CSV. You also need the metadata to describe those things, to tell what they are, what came from where, and the relationships between them. So that's the idea of the metadata. So you see this is a kind of like a transparent box in there. For years, I wondered if that is a bug by the designer or on purpose. I think it is on purpose now because you should be able to see the individual bits of it. So when we did this in previous life, in a sense, by now, we were very focused on workflows, right? We were in the workflow forever project, we were trying to think about preservations of workflows, and we tried to follow kind of the FAIR principles, although they didn't exist back then, but we reuse existing vocabularies and all these things. We made all this bunch of standards and ontologies and so on. But they were a bit difficult to use, I guess you could say. If you were not coming from the semantic web world, but from the real world of just a normal web developer, it is very mythical, right? It is so many things to learn. It's a massive stack and it's not fair. So that can explain why often you don't find people adapting all these wonderful new initiatives people have made. So I met Peter Sefton. Here's a picture from him in the Open Repositories. It's a digital library conference where he was presenting how research object relates to his work on doing a very simple version of this called data crate. So he just wanted to do some JSON and get on with life, right? And we merged together, and throughout a year, basically we made Arrow Crate. So it's basically a lightweight approach to packaging research data and the metadata. So we allowed ourselves to forget all about workflow. He was not coming from the workflow world. He didn't care that much about workflows. He was caring more about repositories and samples and things that people are gathering in the field, in the real world. But we still wanted to keep some of that kind of linked data principles that Michael hinted to, using identifiers, using control vocabularies. It does give a lot of benefits. So we wanted also to use the schema org as a basis. So we didn't have to invent everything again. And you can read more about that. So basically, we come together and we built a community. We put up a GitHub issue 1. So this recommendation, which I don't remember where I got it from now, but it's a very good way to start an open source project. First issue you have is saying how to join the project, right? And we did that. And as you see on the list, we have quite a big list of people from all over the world in different projects. I think about 20 or so maybe are involved in ELIXIR in one way or the other, but lots of people in other fields as well as from the library as well. And we come together to evolve this into some kind of specification that we could then implement. And so that's what it is. It's a very example-driven specification because we're basically just extending schema org, similar to what Carole said about bioschemas. We're just having an opinionated way of saying how you should use it for packaging data, right? So it's just saying, yes, it is JSON LD, but you don't need to worry about it. You're just making these JSON blocks, right? And just do a flat structure. There's no massive graph or anything like that to worry about. Just put your identifiers in here, put your names in here, and so on. And we explain this all by example. And if you see on the side here, you see all these kind of what we call contextual entities that are the kind of things to describe. So we include lots of things in the world, the people, organizations, publishers, funders, grant licensors, and also workflows. We try to sneak in workflows on the side there, right? But also places in the world. So we had the sort of things, photographs of things and stuff like that. I should be able to describe these things as well. So it's very data driven rather than process driven. Later on, or at the same time really, we had the involvement of in-bar schemas, as Carole mentioned, of the computational workflow profile. So that kind of co-evolved with what we were doing and with what was Workflow Hub was doing. So all these things have kind of morphed into hopefully the same thing. So we added this in the latest draft of the Aura Crate. So the previous one was Aura Crate 1.0, which we released after 9 months, I think, of starting the work. And now we're ready for the next version, which is just adding a few things. So it's pretty stable already, the specification. So we're adding how to describe workflows, as Carole described, on a kind of surface level, right? What is the input? What is the output? What is the programming language? How do you run this workflow? So we wanted to add this into our crate as well, so we've done that. Now, in the Workflow Hub, we are using our crate, as Carole mentioned. So you can download things as an our crate. You can also upload by our crate. There's a way to upload more complex workflows that have more than one file. And then you have to provide the Aura Crate metadata file that tells you what the individual files are, right? Because you need to know, for one thing, what is the actual workflow you can run. But it could be test data, which we're figuring out how to describe. There could be documentation and so on. So we have a kind of profile of Aura Crate called our Workflow Aura Crate, which is part of Workflow Hub, that says what particular thing of Aura Crate do you always need to have to be able to upload to Workflow Hub. So even though our crate itself is a kind of profile of schema, or saying this is a way you use this JSON to describe this particular thing, that could be used for many kinds of data and things to package. And if you want to describe workflows, there are a few more things to think about, and that's the role of this profile. And there are other profiles in being involved for totally different things like historical artifacts and so on. So this raises the question about what exactly is it we mean when we say the workflow, right? So I'm funded by the BioExcel project, and then they were doing biomolecular dynamics and things like that. That, again, I don't understand too much about, but it's about simulating atoms at a very low level by doing supercomputing and so on. And we have lots of workflows that we're trying to bring into the world to say how you could run these really quite complicated tools, but in a simpler way to do one particular use case. And so when doing that, we have different use cases as workflows. and we represent them in different languages. So we have CDRL, which we think mainly as a kind of descriptive language, but of course it's also executable. We have Jupyter Notebook, which is much more like a step-by-step, not particularly efficient, but it's good to kind of learn to understand the different steps. And then you can run this at a high scale on the HPC with something called PyComps, which is a kind of annotated Python script. And we're also adapting ELIXIR workflows. So it means one particular workflow actually can have 4 or 5 different flavors. That is really the same thing, kind of similar to what Sarah was showing in the beginning. And what we're figuring out is how to do this in terms of description, right? Because we're managing this as GitHub repositories. We're thinking workflows are source code, right? We have to treat them like that. And that's, you will see often workflow, we're trying to push people into that way. So you see there is a RO-create metadata JSON file added in there. So that is kind of help to describe all the other files that you will find in that repository, but in a structural way, not similar to the README file for humans, but for the computers, right? Tag this file is the workflow, this is the test file, and so on. Now for RO-create, tooling is very important, right? Because people don't really like reading specs. They like to check these things in spec to look up individual things, but they don't want to sit and learn everything from scratch. So luckily we have quite a few developers in that list. So already we have implementations in JavaScript, Python, and Ruby. And Ignacio will finish off this talk by showing the Python one. But we also have, for the Australians, people, they made something called the Scriber. So it's an interactive way of making this on the desktop. So you can learn how to make research of it. And it's very useful for kind of more kind of off-the-shelf data that you just want to describe and put out there. And it will also make you a nice HTML file that describes all these things. So it's ready to put straight on the web afterwards. But a more advanced implementations like the Workflow Hub and these ONI indexer that present the whole website based around the research object. So now I think it's time for Ignacio to talk a bit about the Python library.
Yes. So I will continue with your slide actually. So you mentioned about general usage tooling. So the Python library, that's one of the tools is actually a Python package. So Stian mentioned that RO-create is actually a general packaging system. Is not only for workflows, although some of the developers are using it mainly for workflows. So there's a lot of that into the project. So RO-create by this package is also a general usage. So you can pack and you can also read RO-create containing any kind of payload, that is any kind of data sets. Particularly, I will make an example with a workflow file, mainly because first of all, this workshop is about workflows, but also we've been talking so far that the main idea of metadata is actually makes things machine readable. And if you make a complex example, then it will not be easy to read for humans. So, but if you make a really simple example, then we can go over it just by looking at the generated files. So, as I said, this kind of package has special functions for workflows. Actually, it's pretty much just one special function that does everything. So that's what I will show. It doesn't matter if you really don't know Python. It's just like really easy to understand even if you just look at it as a pseudocode. So the first 2 lines that I'm outlining here are the what's the source of the workflow? That's just one file. In this case, it's a galaxy.ga file. And then you have extra files, which is any kind of extra files you want to include, even if just reference data. It could be files associated with test or anything you want to also include in the packaging. So we have these 2 files in this case, and the main call to create the whole packaging is this one. To the API, you just call make workflow RO-create, and you send them path to the workflow. You send which kind of workflow it is, and you send any extra files that you want to include in there. So then in this workflow create object, you will have the whole package in objects in Python objects file. So besides that, that's the main part, and you can actually just write that down if you don't want to include any extra metadata. But in this case, just as a simple example, I will also add a creator for this workflow. So what you do here is just create a dictionary with the name of the creator. In this case, it's just a name, but you can also refer to it. Ideally, you should refer to it to an identifier, especially if it's possible, an international identifier like an org ID or something like that. Then you add these persons to the workflow create, and you assign this person object as a creator. And then in the last step, you just write a file in a zip file. That's the standard format for ArrowCrate. And what I will show in the next slides is the content of this workflow crate.zip. So if you look at it, we started with 2 files actually, the .ga and the extra file, and then we see that it created at least 3 more files. So these 2 first files that I'm showing here are the ones that we know. That's the file of the workflow itself, and any extra files, for example, a test or reference data input files for something else. So we know what those are. What I will show is the rest of the files. So this one is the abstract CWL definition of the workflow that you just input. In this case, the abstract CWL representation of this .ga file. So I think it's been already mentioned, I think by Carole for sure, what's the abstract CWL? But the abstract CWL is actually a non-executable representation of the workflow, which follows the CWL specification. So what you can do with it is actually contain any kind of, like a general pattern of what the workflow is doing. For example, you can list all the steps, which tools are executed in each step, even though you don't define the version, you don't define any kind of environment, you don't define executional information, but you have an idea of what that step is doing, which kind of input is consuming, which kind of output is producing, and so on. And so having a serial representation, you will have, you can have something like this. And this is actually the format that Workflow Hub prefers. For example, when you're registering a workflow, it also creates this kind of representation. So it's an easy to look representation of what the workflow is doing. So this file, this serial abstract, is extracted automatically by the tool, in this case the ArrowCrate Py, from this .ga input. And this abstract serial, this is something that is under development, but it should be extracted out of any kind of workflow. So any kind of workflow should be represented in this kind of serial abstract representation. So they will all have this kind of representation, and that's one of the main goals of having, for example, Workflow Hub service, where you have a representation is in the same standard for all the kind of workflows that you have. That's one of the goals. So the other file is the ArrowCrate preview. So Stian mentioned that, again, all the metadata is normally handled in a only machine readable format, but it's useful to have also, in this case, an HTML representation of what is actually contained in the package. Because if everything is machine readable, then you open the zip file and you have no idea what's in there. So the ArrowCrate specification says that it may contain an HTML representation, which is a human readable file, which, yeah, again, represents in really not a standard format, but you can put in any way that is human readable the contents of the summarization of the contents of this crate file. So this is also automatically generated by the package, by the, yeah, in this case, the Python package. I won't show it here, but it's quite simple. It's pretty much just a table of the contents. I want to go to the most important one, which is the core file of the ArrowCrate specification, which is the metadata JSON LD. Stian already mentioned about what was the idea behind linked data and so on. I just want to show you how it looks like actually for this case, for this workflow case. So in these files, first of all these lines up to line 20 or something, it's mainly like the header section, and it's mainly about something that is standard defined for all the arrowcrate packages. What is important is the root dataset, which starts here in line 21. You will see it has an ID of dot slash. That's always the case. It's a dataset. And we already see that it has a link to some kind of entity that I will show later, which it has the ID Jaco. That's the ID I assigned to the author. So that's linked, and I will show later what's the whole entity for it. So it has automatically assigned a date of the publication, which is the date of creation. And this section, which is a list of the parts of the crate, is the most important one. So we have a list of all the payload files, the things that you are actually listing in the crate. So we see that we have, of course, the workflow file. We have the abstract CWL file that we created. And we have also the extra file that we identified as part of the crate at the beginning. So since this is a workflow specific crate, the package itself automatically assigned the .ca file, which is the main workflow file, as the main entity. So that's already some metadata that the package extracted automatically. And then, so all these parts are actually linked within the arrowcrate metadata JSON file, and the links are actually also part of the file. And you will see here, for example, the abstract CWL. In this case, it's only the type of files. You don't have any much information about what it is because you don't know what the workflow specifically is. But for the case of the workflow, the .ga file itself, you know, you can see now that how it's tagged with the type of file it is. It's a workflow. It's also software source code, because that's something that the user indicated to by calling the function and saying this is a Galaxy workflow file. Okay, then the package assumes what kind of tags are the standard to identify these kind of files, and then it assigns these IDs, also this external ID, which is internationally understandable. It's just an URL, and it can be linked with any other arrowcrate packages that contain workflows of the same type. I mean, in this case, programmed with the same language. So also the entry for the extra file says nothing much, because we didn't indicate anything. We didn't indicate specific author for this file. We didn't indicate any license or anything about this, but this is also part of the package. You can always indicate the license. For example, in the case of the workflow, you can also indicate any kind of metadata related with the file or any entity. And lastly, you have the full entity entry for the person that is the author of the crate. So that's what I indicated first here. So this author that I created here, it ends up showing up in the metadata file like this. So that's why you are always need, that's more or less the most important thing. So in the end, you'll never end up looking at this arrowcrate metadata JSON. This is only expected to be machine readable. It's only in these really simple cases that you can see what is represented in there. And that's why you always need some kind of tooling. And that's when you need to choose one of the tools that Stian mentioned. And yeah, in this case, I'm just showing up the Python library, but you have a lot to choose from. And I guess that's it, because we are late on time.
Thanks, Stian and Ignacio, for this nice overview of what arrowcrate can do. I want to remember people, you can ask questions in the platform. So there was one question for Stian around, are there templates available for arrowcrate? Do you have examples of that?
Yes, I put in the answer. We do have some examples, but I'm afraid we haven't been too good in maintaining the website to find them. So there are some quite good ones embedded inside the specification. I also put a link in there to all these real-world examples that are talking about documents and things like that.
Yeah. I know we also have some.
What we do need is community help in organizing website. That is always open for volunteers.
And there's also some examples beyond life sciences of using this. I have an additional question. So if for people that are following the European Open Science Cloud nowadays, the fair digital objects is a big topic that's on the table. Could you briefly kind of situate research objects in this kind of area or in this topic? I think that's best for Stian.
Yeah, so we have worked with the fair digital object people, and they have been back and forward at one point, almost reinventing the internet, but now luckily moving a bit further back into standards. I think their main concern is about making objects not just accessible, but interactable, right? So what we've been focusing on research over has been describing things and capturing things, not so much about what you do with it. Sort of our kind of research objects, although they may contain workflows and so on, they're not things it's not a web service. You cannot call a research object and expect it to do something. You would have to give it to some service that then consumes it. So for instance, we're doing testing of workflows like that, right? So fair digital objects are focusing more on enabling richer kind of interactions and hopefully going beyond what HTTP can do and exposing not just the metadata about the object, but also the description of what it can do. There is a warning I would give about make sure you're not reinventing SOAP and web services and things like that, but there is some very important aspects for that, particularly in terms of permanence, using DOIs and so on. And the question is about who is maintaining all this infrastructure that you're then building up. So be aware. We are on Research Hub, we love the web, so we just want to put things on the web, and we know the web has worked well for the last 30 years, so we hope it will work well for a few more years. So.
Thanks, Stian. So we can now move on. You just mentioned testing. So also within the EOSC Live project and within ELIXIR, there's quite some focus on actually testing and benchmarking workflows. And now we will move on to Live Monitor and Open eBench to explain how this infrastructure is being set up. So Simone Leo from CRS4 will showcase Live Monitor, and then Salvador Capella from the Barcelona Supercomputing Center in ELIXIR Spain will then discuss Open eBench. So Simone, will you share your screen?
Yes, in a second.
The floor is yours.
Okay, thanks, Frederik, for the introduction. So Live Monitor is a workflow testing service currently under development as part of the EOSC Live European project. Its main goal is to check that the workflow works as intended to avoid the so-called software collapse, which is a phenomenon according to which a workflow can suffer a loss in its functionality due to causes like changes in a reference to an external entity, or for instance, the dependence of the version of a dependency, or of course in the code of the workflow itself and its tools. So Live Monitor has been developed to test workflows registered in the Workflow Hub, which you heard about in the previous presentation, and report on their status. There are two main scenarios being considered. One where the the Live Monitor acts as a collector of statuses from tests executed on external CI services, and the other where the Live Monitor runs tests internally on its own managed execution environment. And the way these tests are defined is via an extension of the workflows are a crate, which you also just heard about in the previous presentation. So the first scenario is which we will call external testing. In this case, the live monitor acts as like a hub, like a collector for tests being executed on one or more continuous integration instances, such as Jenkins, for instance. And this results information on builds, jobs, outcomes, logs, and so on is collected and exposed through an appropriate API endpoint. So the main client here is expected to be the workflow hub, but in principle, any other client can query the Live Monitor API for this purpose. The other case is where, as I was mentioning before, where the test is defined by the workflow maker through an extension of the workflows are crate metadata. The workflows are a crate with an additional metadata file. Live Monitor, according to this definition, triggers the execution of a test on its own managed CI instance and reports back to the through this the same API endpoint that we mentioned above. So the test metadata is as I was mentioning before, acts as a sort of a plugin for the workflow crate specification, where there is an additional metadata file in the test subdirectory in the crate. In the simple cases, this file may be the only thing present, for instance, for external testing. But in general, it can point to any number of additional files and directories. There are two main ways of specifying tests in this format, which mirror the two scenarios that we just talked about. So in the first case, there is it specifies reference to an existing instance. So the main metadata items are the service type, its location, and the relative path of the relevant job in the CI instance. And in the second case, the definition mainly consists of specifying a test engine type and its version and a path to a file which contains the actual test configuration. The idea here being to leverage existing testing frameworks as much as possible so that the user doesn't have to learn yet another way of specifying test parameters, inputs, outputs, and so on and so forth. The live interaction with the Live Monitor happens via RESTful API being developed with the Open API standard. The main action are, this is like a bit of a misnomer since Live Monitor is not actually a registry, but like posting a workflow, getting information on workflows and its associated test suites, getting information on test suites status, like instances, builds, logs, etc. And finally, some words on authentication. We have initial support for authentication via OpenAuth. So login via GitHub, Workflow Hub, and OpenAuth is also supported by the Workflow Hub. So this is also envisioned as a way to interact with the Workflow Hub. So in the current status, we have an initial support for the first scenario I talked about. So the monitoring of external testing service while the test execution, according to a definition, it's more like exploration or work in progress at this point. That would be all. This is the current team, and thank you for listening.
Okay, thanks. And then we move on to Salva Capella from BSc.
Thank you, Frederik. I hope you can see my screen now. So I'm going to talk a little bit about OpenEvent as a complement, I would say, to Live Monitor presented by Simone. So we have seen a number of pieces, and many of them are fitting together with, with the workflow hub as one of the key elements, but also workflow managers like Galaxy, NetFlow, and so on and so forth. So OpenEvent is a platform dedicated to support technical and scientific benchmarking activities. So in the technical part that we're not getting into that today, we're looking at the different metrics for software metric, as Mateusz was presenting before, and then we're looking at many aspects daily. But today we're focusing in the scientific benchmarking part. So when we're talking about scientific benchmark, we need to consider first 3 angles. We need to consider the technical evaluation of the resources. So when I'm saying resources, I mean web servers, standalone software, workflows, and so on and so forth. So software that actually might be in containers, might be in a bash script, and so on and so forth, just to do a specific activity. Then we should be considering technical, how much memory, how much CPU time, how many input-output operations, and so on and so forth. Then we can also look at the scientific part. So what is the performance of a given resource compared to others, even you're using the same data set for a specific task. And then the other aspect is about the usability. How easy is to use a given resource? What about the documentation, licenses, and so on and so forth? The technical and the scientific ones, that is the one that we're looking at in OpenEvent, are in somehow automatables. So you can automatize the whole process, while the usability is a little bit trickier, because you want to understand how easy to use or what is the perceived usability of a given resource. And that requires end users interaction, and that is difficult to capture in an automatic way. So as I was saying, when we're talking about benchmarking, we're talking about resources, but we're also talking about data. Data, we need to have reference data that represents daily activities and data that represent current challenges. You don't want data that is too easy to solve, because all the programs are going to perform, amazingly good, or you want to have data that is too massive or too complex, that doesn't represent reality. So it's something about having the right data set. And it's also about having the how to perform those activities. You can have benchmarking activities by a single lab, by a single individual, and also you can have the activities of a community. And for us, the role of communities are essential. And they are essential because communities act as a proxy to identify those data sets that I was mentioning before, to identify the metrics, because the communities, those are the experts who are developing the resources. They know what are the relevant metrics to measure the performance, especially the scientific one, and then how to provide an interpretation of those metrics. But also communities can act as a proxy to explore the most feasible space of parameters, because someone was asking before, what about parameters? Well, if we start, trying out all the potential parameters and all the combination that is exponential, or even larger than exponential, so we will not end up exploring all the options. But usually, the community knows a little bit of where the standard parameters and what is the impact of those or changing those parameters. So OpenEvent aims to serve 4 different user profiles. So we have the end user, the one that has a problem and is looking for an answer. So I have this particular problem. What is the best tool to answer that question? What is the best workflow to do that? Then we have the developer. The developer is always looking for reference data sets, metrics, a community to engage with. As I was saying before, communities of developers that get together, or even communities of advanced users. For instance, people at core facilities, they might get together and say, okay, so we're all using the same workflow, but we're using different parameters. Or we're using the same workflows, but the time to run a given workflow is different. And actually, we have some experiences on that. Recently, we took the same workflow in CWL, and that was running in 2 different systems. And in ours, I have to recognize publicly, we were taking 2 times more time than the other one, until we figured out that it was a wrong configuration in one of our machines, our virtual machine. So that is somehow benchmarking technical ones. But also, we can also think of providing information to funders and to funding agencies and policymakers to take the best decisions. Because of course, money is not unlimited. So money has to be, prioritized somehow, and then policies could be also inspired or guided by informed decision. So in the scientific part, we have 3 levels. We have level 1, that is quite easy. It's a data model that allows us to capture the data from the benchmarking efforts and to display that in the website. Simple. Level 2 starts to be a little bit more complicated, because basically what we do is like, we give data, the input data, to every participant. They compute the predictions, the data they want to use for the benchmarking, and they provide that data to us. And then we run a 3-step workflow: validation, metrics, and consolidation, and provide that information to them. So we keep the golden data sets just for benchmarking. So participants don't see the golden data set, so you avoid overfitting, for instance. And then we have level 3. Level 3, rather than we give the participants the data, the input data, participants give us a research object or a workflow, CWL specified workflow, Galaxy workflow, and then we run that for them. So that allows us to have a fair comparison, because the aim is to run those workflows in the same environment. So we can start comparing running time, memory usage, and so on and so forth, but also have other advantages. For instance, the use of controlled data access. Let's say that we have a number of human genomes that cannot leave specific instances or that require permission. So if we get the workflows, we can use that data without exposing that information to them. So level 1 is up and running. Here is an example of a community, the Quest for Orthodox, where we have the expert view, this one, and the non-expert view. So when we do clustering, so a user that is not very familiar with the tool say, well, what is the best one? So here we provide some clustering for a specific event, or for a specific challenge, or for a specific benchmarking challenge. So here we have different resources and different categories, just to say. So then you can have a clear understanding of how they perform. And importantly, here we have a number of web services. So we monitor them. We see whether they are available, up and running or not. But what we want to do in the future is, if any of those entries are a workflow, to provide additional information, maybe together with the colleague from the Live Monitor, to see whether that is available or not, and where people can find it. Might be a Galaxy, might be a NetFlow, where they can find it so they can take it and use it out of the shelf. And that is one of the aims that we have in Open Events. Here we have level 2. In level 2, we have a virtual research environment, so that where people can upload the data, they can have multiple execution, they can compare the performance of their tools against the ones that are public available, and see how the tool evolves. So as we have more communities, we're incorporating those workflows here. And then we have level 3. We're working on that, and that is the reason, because we are really working together with the folks at the Workflow Hub. So we want to use RO-Crate to facilitate the use of those workflows that has been specified and that are public available. So it's not just measuring the scientific performance or the technical performance, but offering the community a workflow that can be used, straightforward. So I have a comparison. I say, okay, I have 20 different workflows. For my particular case, I have this workflow, the best one for the job. So then you can go there, take it, and start running it, for instance, in Galaxy, with NetFlow, or in any other instance. And then we see this, as I was saying before, as a mechanism to work with access control data, the ability to distribute the execution of workflows. Because we are in a supercomputing center, and everyone tends to think that we have unlimited resources. That is not true, because the resources are allocated according to the project. Like you need to submit a proposal, they are approved, and then you have access to project. So sometimes it's easier to have different cloud instances and distribute the effort rather than to have a single installation. And then, of course, this mechanism will allow to check the periodic availability of those benchmark workflows. So we're adding a complementary layer to the work that is being done in Workflow Hub. So our roadmap, we have a co-production model. So we're always open to any community who wants to engage with us. And so come and talk to us to discuss how to engage with us. We are trying, we have started to collaborate with the whole genome Visualify community, led from Charité in Berlin, to implement level 3 together with the DEMBI cloud. So the plan is to execute the control access data using DEMBI cloud, so data that do not leave Germany. And then we have some synthetic data here in Barcelona for the whole level 3. And we will see how it performs. And then, of course, we are actively contributing to different aspects of Workflow Hub activities, because for us it's essential, and we understand there's a community effort rather than reinventing the wheel. We want to contribute to build that wheel that will benefit everyone. So thank you for attention, and I'm happy together with Simone to answer any questions.
Thank you, Salv and Simone, for this overview of the testing of workflows. There's a question in the platform from Jose Maria for Simone. Can Live Monitor provide introspective data about the tested workflows?
Okay, thanks. Interesting question. At the moment, this is not foreseen, since the focus is mainly, I guess, by introspection. We're talking about like information on the metadata about the workflow itself, but that's not really, if I understand the question correctly, that's not really the goal of Live Monitor, but it's rather like checking that the workflow is actually doing it's actually not broken, to put it bluntly, so that the workflow is working. Rather, metadata about information about the workflow is better provided by tools and services like the one we heard before earlier during the course of this workshop. So this is not something we expect to provide. It would be redundant.
Okay, thank you very much. With that, we can go to the last section of this workshop on FAIR by workflow management systems, and I'll hand over to Ignacio.
Yes, so that's a whole section with two parts. First is Galaxy, and then is Nextflow. Just a comment. I just launched a poll. I see a lot of people voting already. It's just to get it started with this section about workflow management systems. And the first one is Björn Grüning from University of Freiburg and ELIXIR, Germany. Björn, you there?
Yes, can you hear me?
I can hear you.
Can you also see this?
I can actually see the slides.
Cool. That's good. So let's start. Yeah, so I will introduce today more or less how the Galaxy community is approaching fair computational data analysis, or the FAIR principles during computational data analysis. And maybe I will start with a short story about traceability. So maybe you know this.
Björn, before you get going, because I know you'll get going wonderfully, can you just take off the images of Stian and Simone from your slides?
Oh, how can I do that?
I think you just, yes, thank you. That's wonderful. I like you very much, but I'd rather look at your slides. Thank you.
Okay, sorry. Yeah, so let me start with a small motivation that we actually are doing more or less regularly. So this paper was dealing with an incident about a very famous bioinformatics tool that is called BLAST. You all probably know it. And there was a documentation issue that more or less people for years, if not decades, used BLAST in a wrong way. You get wrong results and so on. And yes, this is a reproducibility concern. This is in multiple ways a problem. But the interesting part is, if you actually running a portal for data analysis, the question then becomes also about traceability. So not only can you reproduce results, but can you go back in time and find, for example, out which user used that tool on which data set, and can you inform these users, can you retract papers based on that, and so on. I mean, software bugs happen. We know that tools had bugs in specific versions. So can we fix that afterwards? And I guess this is an interesting viewpoint to the entire FAIR principle discussion, that we shouldn't not only be concerned about how to keep track of provenance now and how to capture that, but how do you actually make that searchable also in a long time? So how do you can see back into the past and fix maybe, or at least point people to wrong results, or to things that needs to be fixed afterwards. So with that, I would like to point you out so a few things that we do in Galaxy to actually also enable traceability, as I showed here. So yes, of course, Galaxy can run workflows. So you have this graphical editor where you can more or less click your workflow together in a graphical user interface. You can combine tools freely. But you also can define your workflows in a textual way. So you have them both ways, and you can run them freely. An interesting aspect is also, and most of the workflow management system are supporting that, but I would like to point that out again, is sub-workflows and how you can group actually different types of analyzers together and make them reusable. Because if you have really complex workflows, so this workflow consists of, I don't know, 40 different tools, it gets, no matter which representation you use, it gets really clumpy and you have problems to view that, to inspect that. So grouping them together and have smaller groups, smaller levels that you trust, share them and reusing them is, I think, becoming more and more important if you go into more complex workflows. So sub-workflows is one meaningful way. And what you're seeing here is actually a COVID-19 workflow for drug screening, or how you can design drugs against COVID, which is also in the workflow hub, which Carole mentioned already. You can run workflows in Galaxy either with a graphical user interface where you put in your inputs, or you have a command line utility or a RESTful API to schedule your workflows to more or less arbitrary Galaxy instances where you have access to. So yeah, both use cases work, and both use cases address different kind of users. So keep in mind that we also want to focus actually on biologists, on chemists. So maybe people that don't need to have strictly experience on bash or command line usage. We want to address these users, and we also want to make them using FAIR principles as much as they can. A new feature that was added to Galaxy 2 releases ago is something that we call reports. And reports are dynamically generated reports that are part of the workflow. So if you are a workflow designer, you can include some kind of Markdown definition, and you can reference in Markdown, for example, the parameter of step 3, the first 3 lines of the 5th output in your workflow, and so on and so forth. So with that, your report system and more or less the final PDF that sums up the entire provenance of your workflow becomes part of your workflow. And if you execute such a workflow, you can just point a user or your colleague to a URL where your colleague sees a website that describes everything, but also links out to a certain aspect that you in particular want to highlight. So I think that's a very neat way how we can ensure as workflow developers that certain provenance is actually very, very visible to the user. And maybe as a highlighting mechanism and to point to certain artifacts, to certain details of the workflow. Of course, this gets rendered. So here you see a small example. You execute a workflow. This gets scheduled to the cluster. And once the workflow is finished, you can click on this report and you see more or less an HTML page where you can include different stuff, but you can, for example, also link directly to the existing data. Again, the workflow designer can decide what to include in such a report. We have heard about workflow testing, and I think this topic is really crucial to all workflow management systems. So we need to ensure that this workflow is not only working on our computer or on our CI system. So what we are doing here is we have a bunch of workflows that we ensure that it works across different Galaxy servers even. So this project ensures that the same workflow runs in Australia, in the US, in Belgium, and on the European Galaxy server, for example. And we're adding more and more workflows to keep them running, or at least to notify us if something breaks in between. At totally different aspects, if we talk about workflows, are what we call asynchronous workflows. So like RStudio, Jupyter Notebooks, and these kind of stuff. And yes, people are using it. So people want to use it, and that's fine. That's actually great in my experience. But how do we capture these kind of provenance information? So what we have done is we integrated these asynchronous workflows directly in Galaxy. So you can now have your RStudio instance, your Jupyter instance directly on your Galaxy environment. So next to your asynchronous workflows that you submit to the cluster, and you can interact with both worlds. So in a Jupyter Notebook, you can access data from Galaxy that you have calculated on a cluster. You can start workflows from your Jupyter Notebook if you like. For example, the material science community is doing that. And even more important, these notebooks or the code that you develop in Jupyter or RStudio are also saved to your Galaxy history. So these notebooks become part of your provenance information in Galaxy. So the entire system that we built around capturing all kinds of provenance information and store them in a Postgres database, for example, you can now also rely on that if you use asynchronous workflows like the ones I mentioned. So my controversial question to the audience is a little bit, are workflows actually used? And we have now approximately a few years of data on the European Galaxy server. And what you can see here, for example, is, so currently we have around 80,000 registered users, and they have developed 25,000 workflows. So from these 25,000 workflows, 114 have been executed. This is roughly 6 workflow runs per user, or 1.5 workflow created by a user. So that means more or less, I mean, this is all an average number. So that means that workflows are not super popular, at least not in the Galaxy community. They are used quite often, but you cannot say that actually every user is using workflows. So what are these users doing? And if you think about it, I mean, there are a lot of web servers out there, right? So a web server that just does one single task. And these web servers are highly popular, which is a concern to most of the reproducible researchers and for people that want to cover provenance, because most of these web servers don't put out these informations, or it is at least hard to get these informations from random web servers. But we need to consider this also as a valid use case and that people are actually using it. So how do we actually deal with that? So the point is a little bit going away from workflows. Can we also make tools be fair, in the sense that can we capture provenance information by single tools? And for example, if you have never used Galaxy, this is also what Galaxy is kind of doing. So you have this single tool interface, and talking to different users and looking at our Postgres database over the years and analyzing these provenance data yields actually to an outcome where we need to admit that people are using also complex tools as single tools. So they want just to create a plot. They just want to create a circus plot. They just want to run anti-smash and get their whatever tabular file back. So they treat Galaxy, or they start treating Galaxy also as a single tool interface to run all these tools in one interface, yes, but they don't run complete workflows. So in Galaxy, we still track this provenance, but how do we deal with that in general? So for example, those artifacts we cannot export to the workflow hub. How do we manage that? How do we, I don't know, export that? How do we make that accessible? And one solution, for example, is that we go a step back and annotate really tools properly. So we have now, we generate automatically bioschemas for all our tools. So to make these single tools also more findable so that people get pointed to these tools. We try to nudge people into a direction. If they use one tool, that we say, hey, but now you can also use a second tool afterwards. So to more or less get them into a direction to use more workflows. But I guess my point is to create an alternative to this web server zoo that we have. We actually have now with Galaxy a framework where we can embed these single tools. People can still use their habits of using just a single tool, not creating workflow, but because they are on this infrastructure and this service already, maybe we can then really nudge them into, okay, but now then also do the second step here and the third step. And then we also get all the provenance information. A few last words to data management, because I think that's one key ingredient here. You can capture all the nice things about a workflow, but if you don't capture data, or if you don't manage data carefully, you have obviously a problem with the FAIR principles. So just a few words about Galaxy and data management. So I think we have quite a sophisticated system in place, how we model access to different data sets, how we manage user quota, how we can integrate with different LIMS systems. For example, I want to shoot out here to the ISA tab community and the integration to Galaxy that was added. Finally, this enables you these large projects, like this is again a screenshot of one of these COVID projects. But again, this essentially enables you to run actually an infrastructure out of the box for thousands of users that manages all of a sudden 2 petabytes of storage or more than 50 million data sets. And all of these data sets have associated metadata and quite a rich set of metadata associated to it, which you can then use to train models, to make predictions, etc. Another aspect is how you get data in. So how do you find data? How do you, if you find this data, how to get it in? One new thing that was added to Galaxy that will be in the new version is this plug-in infrastructure for data importers. So you can deploy a plugin that enables every user to get data from a Dropbox account and these kind of things. There's baggage support, so there is already a provenance information kind of that comes into Galaxy. Galaxy can deal with this. Galaxy uses the metadata that comes in and creates appropriate data structures out of it and associates to every data set the metadata that you need. And the same goes for data that goes out of Galaxy. So as already mentioned in several talks, the CWL abstract or whatever we can include in biocompute objects can actually be then exported, stored on the Zenodo or different archives so that we can archive it for 10 years or longer. But Galaxy essentially is a metadata hub that hopefully makes it easy enough to transfer metadata from one data set to the other, from data input to actually staging data out, so that people that want to export a biocompute object actually doesn't need to add so much new information to the final export step. So to answer more or less Sarah's question in the beginning, I guess what we are trying here in the ELIXIR Galaxy community is to create a big enough carrot that we say, we offer you a lot of compute, we offer you a workflow system or a tool system, yeah? So you can easily run your circus tools and don't care about workflows. But, and this is a huge but, if you want to use the system, please, before you go in with your data, annotate your data. And if you go out, because you need to go out with the data at some point, because you have a limited quota and so on. If you go out, please enrich your data with enough metadata so you can easily export it to Zenodo. So the carrot is a little bit the infrastructure that ELIXIR and EOS Glyph is, for example, building, that you get for free. And this is the second aspect, which I think is very, very crucial, that the system that you are using is doing most of that automatically for you and in this smart way. So to make it as easy as possible. If we have both things in place, I really hope that this is encouraging users enough to to adhere immediately to the FAIR principles as we would like. With that, I would like to thank my group here in Freiburg, but also the entire Galaxy community, especially the ELIXIR community, and a special shout out for the data management people in Belgium that made all that also possible. Thanks a lot for listening. Happy to take questions.
Okay, Björn, thanks a lot to you for the great talk. So we do have quite a few questions. So first of all, some questions on the stats you showed about the usage of the platform, whether it's workflow or whether it's tools itself. So Jose Maria is asking, do you have a hit parade of the most popular workflows in a range of time?
Yes, we have that information. The question is if you can share it. So there are two different kinds of workflows. So all public workflows, there we can do it. But for example, workflows that are private to a user or to a group, we cannot give out this data. So we still need to apply to GDPR rules. But essentially, you can do that for your Galaxy server, or we can do that for all public workflows. That's not a problem. So Galaxy in the backend uses a big Postgres database. So our database is several gigabytes in size. And in this database, there's a lot or all provenance information that you need for all workflows, for all tools, for all users. And you can mine this data set according to GDPR. And yes, all these information is in there. So check out your Galaxy server, or I can provide the stats at least for the public workflows.
Okay, fair point. And to add to this, I also have a question. Do you also have stats on workflow reuse? I mean, if people actually reuse the workflow or they start from scratch, even if they end up with some kind of similar things, because that kind of useful for the workflow hub purpose.
So they reuse workflows quite a lot, but they also modify workflows quite a lot. So it's not just that they're using public workflows. As far as we see it, they start using from a kind of the template workflow that they find somewhere, and then they modify it quite heavily. But reusability on workflows is a thing, at least for the pro users that are actually using workflows.
Okay, last one on that, also from me, because we have other questions. So is this kind of usage that is kind of tool oriented instead of workflow oriented? Don't you think it could be also based on the way that Galaxy interface is built? Because I know for sure it has a crazy, incredible backend for running workflows. But if you hit the front end, I mean, if you go for the first time to the front end, the first thing you see is like a lot of tools and not workflows. Maybe that can change, but.
Yes, so I think it's probably how we represent the interface, but I think it's also a natural thing. I mean, exploratory research is first and foremost not you start defining a workflow, but I think that people still map and then they see the mapping results and they tweak parameters and they map again and so on. So workflow building in that sense is probably a very granular process until you end up with something that you would call a workflow. And I think that's how most of the people still work. I mean, it's I'm not sure, but my feeling is a little bit that the minority of people are starting more or less scratching a workflow and designing a workflow from scratch, at least for new data sets or some kind of novel scientific stuff that you still do this exploratory research step by step, and then naturally you create a workflow. But at first it's a very tool focused behavior and interface.
Yeah, it makes sense to build the workflows first, testing the tools and then making the workflow itself. So we have a question from Carole. Is average workflows figure sensible? I would expect that there will be a limited number of workflows that are used extensively, maybe only one or two used in a project. I see the value of Galaxy as a tool portal. Repeat as moved to answer by mistake. Wait, I'm just reading literally. Carole, do you want to comment on this? So it was just like...
It was just that I managed to delete my question and then I put it in again. So yeah, the point here was that you did an average, but of course the world is not really averaged out. It's much more lumpy than that. And so I was wondering if you were being a little bit disingenuous by averaging out there. But while I had the floor, I think developing workflows by example and by variants, i.e. take something and then you vary it, is by far and away the most commonly made way one makes workflows. You build them incrementally, or you take something as a blueprint and then you heavily edit it. This is the way everybody really does things like this. So I agree with you with that. But anyway, are you being disingenuous by doing this smoothing out of the curve, Björn?
Yes, so my problem is still, I'm not sure what I actually can do with the GDPR stuff. So, but the point I wanted to make with these stats is a little bit that we have a lot of users that don't use workflows. And especially, the non-computer driven people are still tending to do it in a more exploratory way. So, I mean, Galaxy makes it kind of easy to have this history and to start one tool after each other. And most of the people stay with that. So they don't use, for example, pretty often the extract workflow features that they say, okay, now whatever I have done, I export it to a workflow and whatever, I run it again. So maybe that's an educational process that we still need to do. Maybe we need to enhance the user interface. But I mean, looking at the numbers of NAR citations, so the web server issue and so on, I think still that outside of our bubble, a lot of people using single tool web servers. Maybe they don't know about alternatives and so on, but I think we should also concentrate on these people, because these web servers are, from a reproducible standpoint, a nightmare. So how can we take that use case, which is, I mean, it's a valid use case, right? It exists. We should recognize that. How can we take that use case, put it in a framework that already adheres to our kind of standards of reproducibility and so on, and maybe make that shift a little bit easier. And once they are in the framework, they can actually then combine multiple tools, and then they will see the benefit. This is kind of my small carrot that I have in mind to point also people out. Yeah, if you just want to run circles, please, but still use Galaxy if you have a graphical user interface, do it. But don't do it on a command line without any provenance information.
Use it as a, I see that. Good.
If I quickly comment on that, perhaps an alternative is to provide user with additional information, the way to use different tools or different approaches to answer the question. A little bit the benchmarking side, like, well, you have different options, you take an informed decision, and if we can associate that with workflows in Galaxy, that will, people will lose the fear of new things and so on and so forth, because maybe they are unsure about the performance of those tools and workflows and so
on. Want to comment on that, Björn? I think that's already somehow implemented in Galaxy, right?
I mean, I 100% agree with Salva. I mean, this is the interlinking or the more or less big picture of Bio tools, where we need to have on every our pages, we just need to interlink to all different workflow engines, all different workflows, and just make people aware. Yeah, this is one crucial part.
Okay, thanks again, Björn. And we have to move on to the last one. This is the last speaker. So we still have a lot of people connected. So I guess they were waiting for Alex Peltzer from Boehringer Ingelheim, Parma.
Hi.
So yeah, he's going to talk about Nextflow, the last workflow management system that we will talk about. We can hear you. We can see your slides. Please go on.
Does this work? Good. Okay, so I'm going to go briefly about over Nextflow and NF Core, which is something different actually than just Nextflow. So I'll introduce a bit what Nextflow can actually do for you, and then also cover what we're doing and trying to do in the NF Core community, which builds on top of the Nextflow as a framework to provide people with analysis pipelines, curate them, and help people setting up analysis pipelines, and also providing some more standardized approaches to actually verify or make workflows more fair, considering new standards coming up now. So we're kind of on the edge of Nextflow pipelines, I think. The community has been growing the last couple of years since it's been founded in 2017. And yeah, so I'm going to go over this. Slides are all available here, and you can also check out the website if you want to at any point. So I think everything is recorded, so you can watch it later as well. Okay, we all know, and everybody is aware of that, what people are doing in computational biology and also biology nowadays is we typically see a new nice method out there. People want to try it on their own data, and what we end up having to do is what most of the bioinformatics people are aware of is you have to figure out how to get this running on your operating system. You have to get a specific version to work with your data. You have to acquire metadata to actually do something meaningful. There's tons of other things and caveats that you have to be aware of to actually get your analysis done and properly done. And also, as we've been seeing in basically all of the talks today already, it's really tricky if everybody can run any type of analysis in general, I would say, but making this in a reproducible way, in a way that everybody else in the community can also rerun the same analysis and come to the same conclusion, that's a tricky bit. That's really tricky bit because people are having different institutions, people are having different infrastructures, different operating systems. There's tons of caveats there, and we all know about that. And I found this little figure here quite nicely explaining all of these caveats here. So just to give you a brief overview about Nextflow, actually you could also check out the nice documentation on the website. There's also recently the Nextflow main developer Paolo Di Tommaso and also Evan Flodden. They published a nice tutorial covering most of the new aspects and also some upcoming sub-workflow aspects of Nextflow in a completely open source tutorial. So you can also check that out. It's actually linked on the main homepage of Nextflow. Nextflow is actually a domain-specific language based on Groovy as a programming language, and it can be used to automate common tasks. You can parallelize the analysis of anything you would like to run in your analysis. It's not just bioinformatics, but there's also people from physics, for example, running stuff with Nextflow. It's quite reliable, so I've been working in a core unit a couple of years, and we've been using that in lots of projects. We're also using it now in the company I'm working now, and there's tons of other institutions working with Nextflow and using it. So it's quite reliable, to be honest, and it works quite easy because we can also have people from a purely biology background being able to run the analysis relatively easily. And the nice thing is, and that's actually the tricky bit normally, is it's not just a bash script or something like that where you might have to have certain issues rerunning this on a different platform, but it's also providing you some tricks and extra features to make your analysis reproducible and follow a fair approach in this case. So it has, as other workflow managers like Galaxy and also other like Snakebake, for example, it provides a so-called executor abstraction. So for example, if you want to run your analysis, your workflow on a Slurm cluster, you can do that. You can also run the same workflow without changing the actual workflow code using a Kubernetes cluster, but you can also push that the same workflow to Amazon and use AWS Batch, for example, or run it on the Google Cloud Platform. And there's actually coming up also Microsoft Azure support quite in the next couple of months, I think. It supports also packaging dependencies in using Docker images. You can package dependencies in Singularity images, in Shifter images. You can also use Podman. There is actually, this slide is very incomplete. So there's many more that are supported. And of course, there's also support for Conda, and therefore also for Bioconda packages. So you can also run your favorite Bioconda packages and use them to encapsulate your tools that you run in your workflow, for example. NF Core, which is the basic distinction between Nextflow and NF Core, which a lot of people need to know about, I think, is a community effort to collect a curated set of analysis pipelines that are built using the Nextflow language or framework, which you would like to call it. And what we're doing there, it's an open source community. It's all on GitHub. It's all open and transparent. Everybody can join. There is no barrier. And everybody can contribute to guidelines. So we provide some guidelines, best practices, I would even say, which came from experiences that a lot of people were making in the community. We provide a set of tools that help you in setting up new pipelines, that also help you in maintaining the code for such pipelines. And of course, we're also providing pipelines. And to come up with, to actually cover what Björn was talking about, pipelines meaning like full pipelines in terms of you input FASTQ files and you get your final analysis out of them. But also, since Nextflow now provides a new feature called modules, so you can also modularize pipelines now or have sub-workflows and meta-workflows. We're also currently working on setting up a repository of modules so that people can actually plug in pipelines after pipelines or even sub-tools after sub-tools if they want to in the future, and also provide some kind of a central repository of these sub-workflows, let's say, in the future that can be used in different pipelines, because we've also experienced that a lot of people are actually using the workflows as they are on the NF Core website, but also we see a lot of people actually taking parts of our pipelines and using them in their own workflows. So we would like to make that even easier in the future, because we think if there's a growing community around this, providing all the metadata for these sub-workflows, it's making things easier for everyone. Some of the standard workflows we provide, is 25 at the moment, are considered stable. So these are curated, reviewed by multiple people normally. So sometimes they are extremely often used. So the RNA-seq workflow is one of the oldest ones, which is one of the most widely accepted ones and might be used. We have a lot of people using in the SAREC workflow, for example, and there's also new workflows that are not as often used, or probably the community behind them is much smaller because it's a very tailored analysis covered in that particular workflow. So for example, coprolite identification pipeline, that's ancient DNA coprolite identification, that's also something very niche, I would even say, but still it's a valid pipeline, and you can actually check out all the pipelines here on the URL as well. All pipelines that we provide in NF Core are tested using GitHub Actions. So we actually help and provide people the means to actually run tests on their pipelines using test data, public test data that is hosted somewhere. And people can then just automatically figure out whether the pipeline they want to use is actually having fully fledged tests, which helps them in also finding out, okay, whether there are issues with certain types of data, for example. We provide, in the tool set of NF Core, we provide so-called linting methods as well. So these are checks that basically are running during the continuous integration service and are checking whether, for example, the code that you just wrote, that's more for a developer, of course, the code that you just wrote, the workflow that you just wrote follows the best practice guidelines that we have. And it also highlights then whether these tests are passing or whether you have warnings. So for example, if the conda package that you are using in your workflow is not up to date, we query the bioconda and conda API and tell you about that, for example. So this is also easing things for people who want to update their workflows quite often, which is also something you have to be aware of, that it's a lot of work actually. So we're trying to help people with also maintaining workflows and not just building and testing them. Another new thing that we've been coming up now, and which we were inspired by others as well, is a so-called JSON schema. So we have a JSON schema now accommodating, coming with each pipeline. So we've released a new tools version that helps people to build such a JSON schema. We have an interactive graphical user interface on the web page that people can then use to fill out a description of the workflow, define all the parameters in there. This is an interactive thing. You can group them in subgroups in this JSON schema, and then finally have that shipped with your pipeline. So it's more like a metadata description, and people can then, for example, go on the web page and just go on NF Core Launch, select the version of the workflow they want to run, click on Launch, and then they get to input options. And that also contains all the documentation. So what we're also doing now is we're rebuilding the documentation from that JSON schema in a markdown format on the web page. So people coming to the web page will basically see a one-to-one synchronized version of the help that comes with the actual pipeline, and also synchronizes almost immediately with the parameters actually available in that workflow. So we try to, because we found that it was very difficult for people to also update all the documentation every time they change something even minor in their workflow, in their pipeline. So that should hopefully help a bit. And once you're done with saving these parameters that you launched on the website, you can even go now, either you use the NF Core command line tools to run your workflow now, NF Core Launch, you just type in an ID that's a hash, and we delete these files immediately after running that. Or you can just click on Nextflow Tower, which is a new feature developed by the Nextflow developers actually. So it's basically a web service that you can then use to launch a workflow across multiple cloud providers, or even on your local premises soon. So this is basically the Nextflow Tower view that you get. So you kind of get a nice little web interface now, where you can also see whether your workflow worked well or whether processes are failing. It's like an interactive way to see what's going on. We've recently also started providing mega tests. We call them mega tests because the standard CI tests that we enabled in the Nextflow and NF Core community now are actually just small test data sets with a couple of megabytes, or sometimes even a couple of 100 megabytes. But the AWS megatests is something that we've been coming up after getting a grant for AWS, from AWS actually, to run full-size test data sets. So what we do there is we benchmark all the pipelines hosted on the NF Core community using GitHub Actions, AWS Batch, and Nextflow Tower to actually figure out whether they also hold true and work well with large-scale data that you would typically also use in your daily analysis, and not just some tiny test data, because sometimes you see issues coming up only if you really run large-scale data. For example, memory consumption might be very different from your local small test data sets. So the NF Core community has been growing quite substantially since the last couple of years. So we currently have 840 people on the Slack, 1,400 people on Twitter, for example. We have 55 repositories, thousands of commits, and people are actually quite eager to get their own workflows in the NF Core community, also get feedback on workflows. It's a very open thing. I found it very transparent and nice. But I'm not the one person telling you about that. I think the easiest way to find out is if you just join and check it out and have a look at it. Some of the steps we've been taking also after this year's BCC BOSC. So there are some approaches that we try to make NF Core pipelines more fair. So some of the steps we've been taking was, for example, to support to have NF Core pipelines also listed on docs. So this is already supported. So they implemented some features to make that possible, to also have that automatically set up. We're working on providing a means to export to RO crate format. Currently, there's just a prototype. We've been trying some stuff out, getting some feedback from people there, but that's currently an ongoing thing. We're evaluating the workflow hub, of course, because we've also been, so Phil, for example, was having quite a lot of discussions after the BCC BOSC this year to talk about that. And we've also thought about considering bioschemas in the future, but we'll stick with JSON schema for now and probably update at some point if there is some easy way to do that. Okay, apart from that, as I already mentioned it briefly a couple of times, it's open for everyone to join, contribute, and use. Even if you just want to use subparts of it, you're very welcome to do so. It's an open source community. We even have a new code of conduct now, and welcome everybody who wants to join. So I'm open for questions now.
Great, thanks, Alex. Yes, so officially we are over the time, but we did get an extension of 20 minutes. So for all the participants that are still around, we have 20 more minutes officially. We'll go to questions and then we'll do a wrap up. So questions for Alex. So does Nextflow have a mechanism to obtain a detailed list of workflow input parameters, workflow steps, and their interrelationships, like a graph, without running the workflow itself? It says projects like workflow need that information in order to generate an abstract CWL.
So that question, if I understood it correctly, that question goes down basically, what Nextflow can do is it can create a graph, a direct DAG format graph in the end of a workflow run, but it does not pre-compute such a graph, such as SnakeMake, for example, can do for you. SnakeMake has this possibility, for example, to create such a graph structure and define these, but and have like a graphical or visual visual way to tell you, okay, this is how your workflow looks like. Nextflow creates that as well, but it will do that when running the workflow actually. So you can actually export that as a visual image as well if you want to. But okay. Due to the model in the background of both workflow management systems, SnakeMake can do that as a dry run, for example, whereas Nextflow cannot do that. That's a difference between the push and pull model, I would say.
And one more from Jose Maria. Does NF Core community has some agreement about how to embed programmatic annotations, like ontological ones, attached to inputs, processes, or outputs in NF Core workflows?
At the moment, no, we don't. The only thing we've so far wanted to have as additional metadata was exactly the JSON schema, because we wanted to have at least some sort of support for something going down that direction. But at the moment, we don't have anything like what Jose Maria was proposing. So, but we are very open for any discussion. So if there is somebody around and wants to contribute that or even suggest implementing that, we can of course have a chat and discuss it. We're very open to that.
Okay, and I have a question. I've seen that at least the pipelines in NF Core, they normally rely on iGenomes project to get the reference data. I'm talking about genomes specifically. Do you have an option to actually use some other project to get the reference data from somewhere else, or do you plan to include some other projects?
Yes, we do. So the iGenomes project was kind of a, it was a pet project, or is a pet project of Phil Ewells, one of the founders of NFCO. Therefore, it was integrated all over the place. But in the end, there's also a project called RefGenie. Some of you might have heard about it.
Yeah,
which
I'm asking
is
specifically about that. Yeah.
Yeah, we've been in close contact with people there. So with Nathan Sheffield from the group that develops the RefGenie, and we are really in close contact with them and quite eager to implement that and get it rolled out across all NF Core pipelines, which is of course more for the genomics part, but we also have a lot of people from proteomics who also asked for something similar from a proteomics field. So there might be some more things coming up very soon. Yeah.
Awesome. Yeah, RefGenie is the way to go, I think. Okay, that's it because we are running out of time. We just do a wrap up. But thanks again, Alex, for your great talk.
Thank you.
Now I will share the screen. And Carole, if you wanna join for a wrap up.
Yes, I can help a wrap up. Hopefully you found these presentations and the question and answering session useful and interesting. Recollect from the beginning of the session, we kind of used this as a bit of a roadmap to talk about the FAIR workflow infrastructure used in ELIXIR. And I think we've touched on the majority of these different components. So hopefully this will make a bit more sense now, as Sarah said right at the beginning, that one needs to be able to find things. So registries are important. The transformational effect of containers from the point of view of portability and reproducibility, the range of different workflow management systems to actually execute. And we heard some lovely talks from Björn and Alex about the very rich properties that their workflow systems have, and also, and importantly, the importance of testing, benchmarking, and provenance, which I think was a very strong theme. Next slide. Got any extra slides? Yeah. So we have some discussion topics, but before that, can I encourage everybody to complete the poll if they haven't done the poll so far? It already has some quite interesting results that we can see. We only have 14, I think only 14 votes so far in the poll, if I understand this platform correctly, and we have 88 participants on the call. So that would suggest to me that there are many more people who could answer these poll questions. We have several discussion topics, although we have a very small amount of time to discuss them. But the things that we raised here were things like, which features would you expect from a registry? What is the role of a workflow management system in this ecosystem? And we've already heard from Björn and Alex what some ideas there. What are your experiences of major bottlenecks for publishing FAIR computational workflows? And indeed, just tools. What are the priorities? And what is key for users to adopt this infrastructure? And I think actually already Björn started quite an interesting debate about that. in order to, I know that several people have said, where do we go on after this to discuss all of these different aspects? Each of the presentations had community, particularly those who are providing communities. So for example, Nextflow and Galaxy, they have their own communities, of course. And there are communities for CWL, Workflow, Hub, the research objects, and so on, that are all, were all listed and will be available in the talks. But I suggest perhaps that a useful thing will be to consider looking at the Galaxy tools platform, because the Galaxy tools platform unites and brings together all of these different communities and activities, and attempts to kind of create an umbrella environment for them. So I would encourage you to go to the Galaxy website and look how to do the tools platform. And if at all Jen Harrow is on the call, I wonder if Jen would like to say a word in that direction. Is Jen still there?
I don't think she's in the call.
Carole, I think she cannot say anything because she is a participant.
Yeah,
so we can't actually give her the floor. Okay.
Not in a fast
that's
way.
Well, I'm sure that Jen Harrow, who I will speak on her behalf, who is the tool coordinator, tool platform coordinator, could speak to this, but we do still have Björn. And Björn is a ELIXIR Tools EXCO member. So perhaps Björn, you would like to say some words about how all of these good people on this call could participate into the tools platform, and also Salva, of course, as well, is also in the same position. Perhaps Björn and Salva would like to make a few words about how to join the ELIXIR Tools platform.
Yeah, I mean, the ELIXIR Tools platform is really broad. So it contains projects like BioConda, BioContainers, Galaxy, other workflow management systems, but also benchmarking. It contains the talk that you have heard about, best practices in general tool development. So how do you actually set up a software project? And all these projects are driven very openly. So we gather together on GitHub, exchanging ideas, trying to drive these projects further. And wherever your interest is, just approach us, join our mailing lists, join these projects. So most of them are on GitHub, for example, to chat. So you don't need to have any invitation, just join our GitHub chats and ask questions. So I think we cover a very broad range of bioinformatics. So no matter if your interest is in benchmarking or metadata or actually packaging, this is all what we care about. And this is all what we develop. So please feel free to join us.
If I can add very briefly, I will say that we are quite friendly. And by starting or by getting in touch with the tools platform, you can also incorporate into ELIXIR. For instance, Carole, she's a ESCO member of the interoperability platform, but she's doing a lot of tools. So we tend to work together a lot, and that might be a possibility. And also with the compute guys and so on and so forth. So we're not a closed club, so it's just to facilitate everyone's life.
So thank you for that. Do we have any additional current questions or any issues, that discussion or immediate thoughts that the community, those people are still on the call, the 85 of you still on the call against these discussion topics? I'll just wait to see if, or perhaps even from the panel. We already heard some strong opinions from Björn, which I very much enjoyed, but perhaps other panelists would have a view about what they think are perhaps the next priority for the ecosystem. He proposed a priority that will be to really address those people who just use one tool. perhaps Stian or Michael would want to say perhaps what you think. And Sarah, what do you think your top priority would be? Everybody's tired.
No, it was difficult to unmute me, sorry. I was looking for, but give me 5 minutes to really think about it. If I have only like to say.
I was just verifying my slides.
So in 5 minutes we will finish. The session will automatically shut. So that's a very well sidestepped comment there, Sarah. Well done.
I think we see from the presentation that kind of all ingredients are there, right? We have no excuse, right? It's not that much effort needed, but we're not all on quite the same page. We're still going a slightly different direction. And the big challenge is how to get the average user to contribute whatever minimal things we need in order to get all the big extra side effects, right? So it was mentioned, get them to provide the reference for where the data come from, things like that. These are the kind of heavy tasks that nobody wants to face, right? But it is the biggest barrier for adaptation that we have to face. So the more that can be done automatically and carried along as you move from one system to the other, the better, right? So the user don't have to think about it, but it just comes there and they get lots of nice shiny links or whatever for free. And I think that is the big challenge, because we know people are not married to one particular workflow system. They may have their favorites, right, that they try to use, but sometimes they hit the wall because they're using it beyond its capabilities. And then all the hacks come in. And we have to acknowledge that's part of it, right? So they have to be part of this ecosystem as well.
If I can say something very, very briefly, I would like to challenge the audience in the sense that for the next project, rather than start directly coding and using the standard ways of, single tools, individual tools, and so on and so forth, invest 1, 2, 3 days to use the tools or the system that we are all together building. And you will realize that soon you will making the transition to that. Because once you make the transition to start using this kind of verified workflows and the use of containers and so on and so forth, that is I would say a life changer. I did it a few years ago, and I cannot imagine myself just having specific scripts running in Bash. That is not, I cannot imagine myself doing that anymore.
You're a brave man to have admitted that. I noticed that in the poll that we have 27 votes, that I see that 35% say they've never used a workflow management system, which I found quite interesting. And those who have come across problems they've come across when using a published workflow is, as you say, technical issues and additional input files are missing. So key things missing, which I think is something that Stian raised there, in fact, it's gone up now as we speak, 50% technical issues. Just the sheer issue of dependencies, environments, installations. And this is actually a big obstacle that can't be overlooked. And perhaps this speaks to Björn's point about if you sidestep that by providing an environment where that is actually effectively done for you, through say a Galaxy instance, then that's a step in the direction of easing the path. I also note, just looking at the poll, that 85% of those who polled do actually annotate their workflow files with human language, but only 7% with what might be machine processable language. So Stian, your plea for fair principles and fair workflows being about machine readability has 93% way to go, according to this, which I think again is a very interesting challenge. But then, and then the final question, which is how do you normally share your workflows? GitHub is the out-and-out winner. So this is a clear indicator of a direction, which I know in Workflow Hub, we're definitely moving in that direction about using GitHub. But GitHub seems to have really cornered the market there from the point of view of workflow sharing. So I think we're coming up to our the clock ticking, and our extension is kind of timing out. So at this point, I'd like to thank everybody in the audience for staying with us, for the 79 of you who stuck with us. Congratulations, and particularly as you went beyond the finishing line. Very much appreciate that. And can I also thank as well all of these excellent speakers. I think it's been an excellent session, really stimulating speakers, really thoughtful presentations, really exercised the whole idea of FAIR, as well as computational workflows, and in particular FAIR and computational workflows. So if we could kind of, we cannot have an applause from the audience, but we can applaud each other. So so I'd like to thank you very much, and thank you. And I'll remind you that we will be making all of these slides available. I actually put into the Q&A a link to the document. We will be putting and I believe that they will be linked off the official website in due course by the organizers. And this whole session was recorded and will come available to us from the organizers. And can we also thank the organizers for setting up such a nice interactive system and all their help in these challenging times where one has to do these things interactively. I know it's not ideal, but I think this was as pretty good as we can get given the circumstance and the number of people. So thank you. And can I also thank particularly Ignacio for doing all of the heavy lifting. So thank you very much, Ignacio, for all of your excellent work in sorting out.
Yay!
Thanks to you, Carole, because you also did a lot. So yeah.
Yes, that's very kind of you, but I was going to keep quiet about that. Okay.
Somebody needs to say it.
So thank you, and enjoy the rest of your day. And I hope we find you next time working on workflows.
Hopefully, see you next time then.
Bye-bye.
Till next time.
Bye.
Thank you
Bye,
very much.
everyone.
Bye. Thank you very much.
Bye-bye.
Bye.